Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Welcome to Space News from the Electric
Universe.
In our previous episode,
we celebrated the 5-year anniversary of the debut of Space News from the Electric Universe, with a comprehensive overview of the historic space missions to comets. This overview provides a compelling demonstration of the respective successes and failures of the theoretical predictions of standard comet theory versus those of the Electric Universe. None of the mission findings support the standard view of comets as electrically inert, dirty snowballs that slowly sublimate as they move toward the sun. All of the findings support the electrical view of comets as dry, rocky bodies that become electrically active in response to their changing plasma environments. The startling truth today is that institutional science no longer has a coherent theory of comets in the face of insurmountable falsifying evidence. Nevertheless, we are still told that comets are conglomerates of ice and dust that formed 4.5 billion years ago, the leftovers of a solar system formed in a swirling disk of gas and dust. However, many decades before the technically remarkable missions to comets, the basis already existed for a radically different view of comets. In fact, perhaps unbeknownst to many scientists and laypersons, electrical theories of comets have been proposed by dozens of researchers dating back centuries. As author and historian Hannes Teger has demonstrated in his remarkable historical research, for at least the last 2.5 centuries, various astronomers, physicists, and natural philosophers have hypothesized that cometary phenomena are basically electrical. An electric comet means that the assumption of charge neutrality applied to space objects at all scales cannot be correct. But the case for electrical comet activity has only grown stronger with ever finer technological data. Comets have been a source of mystery for centuries, and there's no debate that mankind viewed comets with awe and terror for millennia. In modern times, the list of observed cometary phenomena that defy all standard explanation is tremendously daunting. Let us begin our systematic analysis of the mysteries, comparing the standard predictions and explanations versus those of the Electric Universe. Comets breaking apart. In the 20th century, with the dawn of the space age came unprecedented opportunities to observe increasingly remote comets as they moved toward our region of the solar system. An imposing enigma quickly emerged. Astronomers began observing comets that broke apart or disintegrated at amazingly vast distances from the sun, for no readily apparent reason. As far back as 1957, Comet Virtanen split while inside the orbit of Saturn, well over 800 million miles from the sun. And a similar thing happened to Comet Biela-Lambert. In 1976, Comet West never approached closer than 30 million kilometers from the sun. So when a disruption occurred and the comet split into 4 fragments, astronomers were shocked. More recently, the explosive breakup of Comet Linear in the summer of 2000 provoked even greater amazement. The event occurred well over 100 million kilometers from the sun. In fact, Carl Sagan and Anne Druyan, authors of the book Comet, reported that 80% of comets that split do so when they are far from the sun. In stark contrast, scientists must explain the question of why some comets pass extremely close to the sun and yet do not disintegrate. Obviously unexpected if comets are sublimating ice balls. An extreme example of this puzzle came in 2011 when the perihelion of the Lovejoy comet C2011W3 brought it to within 140,000 kilometers of the sun's surface. As seen in this video, the comet survived intact after more than 1 hour in the sun's corona. In a paper in the 1960s, astronomer Dr. Brian G. Marsden highlighted the unsolved mystery of comet fragmentation. He noted not only the problem of the fragmenting comets' distance from the sun, but also the relative velocity of their separation, far greater than could be due to solar heating. He wrote, "Although most of the comets observed to split have done so for no obvious reason, one really does require an explanation when the velocity of separation is some 20% of the velocity of the comet itself. A collision with some asteroidal object at 200 AU from the sun and 100 AU above the ecliptic plane, even though it would only have to happen once, is scarcely worthy of serious consideration. But more than half a century after the publication of Marsden's paper, astronomers certainly do still entertain extraordinarily improbable cometary collisions, such as the case with the comet 67P, whose double-lobed form astronomers have attributed to two comets colliding and sticking together for some reason. The aforementioned Sagan and Druyan may have found a clue to the unresolved problem of comet splitting, though without recognizing its significance. They wrote, "Splitting and jetting may be connected. At the moment Comet West split, the individual fragments brightened noticeably and propelled large quantities of dust into space in the first of some dozen bursts. The same was also true for the breakup of Comet Linear in 2000. But why would high-velocity jets and explosions of dust traveling at supersonic speeds precede the fragmentation of a comet nucleus? In the electrical model of comets, the answer is obvious. Comets have never been successfully explained in simple mechanical terms because they are electrified bodies orbiting within the plasma environment of the sun. Like any good conductor, the electric field within the plasma is very low. But unlike good metal conductors, the solar plasma is of extremely low density, and therefore its current carrying ability is limited. Comets must adjust to the changing plasma potential as they move radially toward or away from the sun. On the long, slow journey through the outer reaches of the solar system, the adjustment is not so difficult. But it does often involve visible electrical discharge effects as a comet races through the inner solar system. The comet nucleus behaves like a capacitor, and if a discharge occurs within the capacitor, it can explode violently. This does explain why outbursts that precede comet fragmentation are far more energetic than could possibly be explained by sublimating ices. The electric universe interpretation can also explain the sudden and unexpected brightening of comets at extraordinary distances from the sun. In October of 2007, the comet Holmes 17P stunned astronomers around the world when it suddenly brightened by a factor of 1,000,000. In less than 24 hours, it grew from a small 17th magnitude comet to a magnitude of 2.5, so large it was easily visible to the naked eye on Earth. Holmes's coma continued expanding until by mid-November of 2007, it had become the largest object in the solar system, visibly larger than the sun. The coma's diameter had grown from 28,000 kilometers to 7 million kilometers. At the time of Holmes's extraordinary display, the comet was actually moving away from the sun, and therefore cooling. Among the common sense questions posed by the enigma, how did such a gravitationally minuscule body hold in place a uniform spherical coma 7 million kilometers in diameter? If Holmes's flare-up was a result of a collapse or explosion, as some scientists speculated, why was the ejected material not asymmetrical, as one would anticipate from an explosion? Why did the claimed explosion not produce a variety of fragmentary sizes, instead of the extremely fine dust that was actually observed? What explosive event could have caused the comet to illuminate for months, rather than the seconds typical of an explosion's luminescence? Why did the comet's gaseous, dusty, spherical cloud persist for months, rather than dispersing quickly away from the comet? Unfortunately, the science media and the astronomical community had barely anything to say about Comet Holmes. This seems nearly unbelievable, considering the enormous interest the comet generated around the world. As Thunderbolts contributor Scott Wall explained in his 2008 article, Comet Holmes, a media non-event. You might think that this remarkable behavior would be big news, particularly among astronomers. A prominent astronomy magazine recently published their top 10 news stories of 2007. Surprisingly, this spectacular comet was not named as the top story. It didn't even finish in the top 10. In fact, the entire magazine completely ignored the comet. There was not even an editorial comment. Additionally, there was little, if any, newspaper or TV coverage. Holmes's spectacular brightening was reminiscent of a, quote, surprising display several years earlier from the comet Hale-Bopp. As seen in the photo on your screen, Hale-Bopp was too far from the sun for a, quote, dirty snowball to melt, but it already displayed 7 jets.
That's another way of them suppressing the information. You know, just limiting the data that you can use to make more informed decisions about what these things are. Sure. We see an anomalous effect, and it defies our models and theories 100%. What do? We ignore it. Yes, ignore it. Must maintain the dogmatic theories. Must maintain. Does not compute. No data does not compute. Danger, Will Robinson.
For years after Hale-Bopp left the inner solar system, it was still active. It displayed a coma, a fan-shaped dust tail, and an ion tail, even though it was farther from the sun than Jupiter, Saturn, or even Uranus. The comet's tail was shrinking, but it was still about
Refresh
5
your
times
browser,
longer
buddy.
than the distance
Playing for
between
me,
the
okay.
Earth and the Moon. At such a distance, if solar heating could melt ice, then one would expect that the icy moons of Saturn and Jupiter would be as dry as our own moon. Again, the electric comet theory states that dramatic cometary displays arise from the electrical
Tigers, we know how to
interaction
harness
between
the
the comet
electricity. It's
and the
really
solar
simple,
discharge plasma.
Long pole
In
into the
fact,
ground going
considerable
straight up
evidence
into the air.
exists that the electrical relationship
There you
between
go.
comets and the sun is not one-sided.
Simple. So
Dating
simple.
back decades, astronomers have noted numerous so-called coincidental incidents of CMEs corresponding with an approaching comet. The consensus theory remains that no connection between the two events can exist because of comet's insignificant size compared to the sun. However, many recent findings lend credence to the electrical interpretation. Consider scientists' baffling discovery in 2007 that the comet Magnat was somehow able to modulate the solar wind. NASA's Ulysses spacecraft encountered the comet when it was passing close to the planet Mars. Scientists detected that the comet's tail had slowed the solar wind to half its normal speed. Space science professor Dr. Michael Comey said of the discovery, "This was very surprising to me. Way past the orbit of Mars, the solar wind felt the disturbance of this little comet. It will be a serious challenge for us theoreticians and computer modelers to figure out the physics." But perhaps the greatest confirmation that comets are electrically charged bodies is the spectacular displays, completely unexpected by astronomers, of comets that have closely approached planets in modern times. The most dramatic such display came in 1994 as the comet Shoemaker-Levy 9 approached the gas giant Jupiter. Prior to the encounter, astronomers predicted that the comet's influence on Jupiter would likely be as trivial as pebbles falling into an ocean. But as we have repeatedly outlined on this series, the effects were both more dramatic and generally inexplicable in standard reasoning. The anomalies included unusual and energetic auroral activity immediately after the, quote, impact of the largest Shoemaker-Levy 9 fragment, as well as the disruption and amazing brightening of radiation belts, and unexpected X-ray emissions. As Michael Klein of JPL said in an analysis of the events, "Never in 23 years of Jupiter observations have we seen such a rapid and intense increase in radio emission. Extra electrons were supplied by a source, which is a mystery." Visit the link in the description box of this video for Wal Thornhill's in-depth analysis of the Shoemaker-Levy 9 puzzle. More recently, comet sighting Spring presented a similar shock to astronomers in its close encounter with the planet Mars. NASA's Maven spacecraft measured the effects of the encounter on the Martian atmosphere. According to a NASA report, debris from the comet added a temporary and very strong layer of ions to the ionosphere, the electrically charged layer high above Mars. Maven team member Jared Espley said of the comet's astonishing influence, "We think the encounter blew away part of Mars's upper atmosphere, much like a strong solar storm would. The main action took place during the comet's closest approach, but the planet's magnetosphere began to feel some effects as soon as it entered the outer edge of the comet's coma." This brief summary offers only a glimpse of the still growing list of, quote, surprising comet discoveries. But is it a coincidence that the electric comet theory predicts and explains all of the so-called mysteries? As we will see in our next episode commemorating the 5-year anniversary of this series, comets are just one of countless phenomena that only affirm the electrical nature of the universe.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. August 26, 2017 will mark the 5-year anniversary of the inaugural episode of the science video series, Space News from the Electric Universe. The Thunderbolts Project created this series as an opportunity for its chief principals and many contributors to offer analysis and explanation of space science discoveries in the world today. For many years previous, members of the Electric Universe community had become increasingly aware of the remarkable predictive successes of Electric Universe theory versus those of the standard cosmology. But it's also apparent that a disturbing disconnect exists between science discovery and the direction of the theoretical sciences. Many of the most significant space discoveries, completely unexpected in standard reasoning, seem to rarely, if ever, force any meaningful reassessment of foundational theory. Other discoveries seem to have been forgotten entirely, disappearing down a memory hole and never mentioned in science literature again. Therefore, we shall now begin a comprehensive summary of the amazing content we have covered in the last 5 years. And as you will see, at every scale throughout the universe, the ability of the Electric Universe theory to both predict and explain discovery has never been more evident. In recent years, there have been unprecedented opportunities to learn about the nature and origins of one of the most mysterious objects in space, the comet. The Electric Universe has always offered an interpretation of comets that radically differs from standard theory. Comets are not dirty snowballs. They're primordial icy leftovers from the solar system's formation 4.5 billion years ago. Comets, as well as asteroids and meteoroids, were born far more recently, formed by electrical discharges from the surfaces of planets and moons. Because comets are not icy bodies, they do not slowly sublimate due to solar heating. Comet activity, including the production of comet jets and a cometary coma, is electrical activity. The detection of signatures of water molecules in cometary coma is due to electrochemical reactions at the comet, as we'll explain further later in this episode. In fact, the findings of increasingly ambitious comet missions have overwhelmingly confirmed the predictions of the electrical model. Combined, the list of surprises amount to the clear falsification of standard comet theory. One of the many game-changing surprises came as far back as 1996, when the Ulysses spacecraft encountered the ion tail of Hyakutake. At the time, the spacecraft was more than 360 million miles from the comet, or roughly 4 times the distance of the Earth from the Sun. The belief in electrically neutral objects in space has prevented mainstream scientists from confronting the obvious conclusion of this discovery. In order to remain intact over such a stupendous distance, rather than dispersing like a gas in a vacuum, the comet tail must carry an electrical current to confine the material and prevent its dispersal. Electric currents in space, traveling through the conductive medium of plasma, take the form of twisted filaments known as Birkeland currents, which look a bit like braided copper wire. In fact, in decades subsequent to the Ulysses encounter with Hyakutake, the Birkeland currents in comet tails have been imaged in ever finer detail, clearly confirming their electrical nature. The emission of X-rays from Hyakutake also shocked comet investigators. As Dr. Michael J. Mumma wrote about the discovery, astronomers decided to look at Hyakutake, and they were shocked by what they saw. Rosad images revealed a crescent-shaped region of X-ray emission around the comet 1,000 times more intense than anyone had predicted. We had no clear expectation that comets would shine in X-rays. Comet scientists responded with the ad hoc notion that the sun was entirely responsible for the X-rays, suggesting that the solar wind scavenges electrons from a cometary atmosphere, resulting in a recombination sufficient to generate the observed X-rays. The surprises in comet science continued and intensified. In 2001, the NASA spacecraft Deep Space One captured the finest image to that time of any comet nucleus. What scientists saw bore no resemblance to the dirty snowball of standard theory. The leader of the mission's imaging team said at the time, "It's mind-boggling and stupendous. These pictures have told us that comet nuclei are far more complex than we had ever imagined. They have rugged terrain, smooth rolling plains, deep fractures, and very, very dark material." Scientists were also stunned when they found that the flow of ions around the comet's nucleus was, quote, not centered on the comet's nucleus as scientists expected before the Borrelli flyby. But none of these findings forced any real reassessment about the nature of comets prior to NASA's Stardust mission in 2004. In fact, a microchip riding on the Stardust spacecraft was inscribed with the following pronouncement from Fred Whipple, the father of the Dirty Snowball comet model. Today, we know that comets are black and cold, consisting of ices and dust that coalesced from an interstellar cloud as it collapsed before the solar system. So it's no wonder that
New rabbit holes.
Hold
on a second.
Completely baffled by the Stardust findings and Comet Build 2. The surprises begin with the comet's visual appearance, which was desiccated, complex and rough, rather than icy and smooth. A major shock was the presence of so-called impact craters on the comet nucleus, as reported by New Scientist in 2004. That is completely unexpected because comets are believed to be loose aggregations of dust and ice that would shatter on impact. If the pits are craters, the surface of the comet nucleus must be much stronger than experts thought. NASA's Ray Newberg said of the
Quite an
discovery,
odyssey there.
I don't think any of us ever really considered the possibility of impact craters. It may be a well-cemented rubble pile, but it's definitely not a loose, powdery surface. When scientists on Earth tested the Wilt 2 dust samples, what they found was so unexpected they initially thought that the early sample may have been contaminated by the spacecraft. Rather than the expected ancient interstellar grains, the Wilt 2 dust grains were much larger than expected and contained minerals such as anorthite and diopside, which require temperatures of thousands of degrees. NASA curator Michael Zelensky said of the discovery, "That's a big surprise. People thought comets would just be cold stuff that formed out where things are very cold. It was kind of a shock to not just find one, but several of these, which implies they are pretty common in the comet. Unfortunately, neither these nor the many previous astonishing comet discoveries seem to force any reevaluation of comet theory prior to the Deep Impact mission for Comet Tempel 1 in 2005. Scientists still assumed that comets were dirty snowballs that accreted 4.5 billion years ago. But the chief principals of the Thunderbolts project felt confident that the NASA mission would only provide support for the electric comet model. Prior to the July 4, 2005 impact date for the Tempel 1 probe, Wallace Thornhill and David Talbot issued a series of predictions for the event, which were published on the Thunderbolts.info website. Because of the comet's low eccentricity orbit, they wrote that electrical interactions with the approaching probe, quote, may be slight, but they should be measurable if NASA will look for them. The most obvious would be a flash shortly before impact. And they predicted that temperatures associated with the event would be, quote, much higher than expected from impact heating. They also predicted more energy will be released than expected because of the electrical contributions of the comet. And they predicted that the impact crater left by the NASA probe would be smaller than expected because the comet is rock, more similar to an asteroid than a loose conglomeration of ice and dust. These predictions, as well as several others on the comet's composition and surface terrain, received stunning confirmation. Moments before the 800-pound copper projectile struck the comet nucleus, NASA scientists were amazed by the bright electrical flash, shortly followed by an explosion much larger than they anticipated when the impactor contacted the surface. As NASA investigator Peter Schultz said at the time, what you see is something really surprising. First, there is a small flash, then there's a delay, then there's a big flash, and the whole thing breaks loose. Nor did the projectile leave nearly the dramatic impact crater scientists had predicted. Just one piece of evidence that the comet nucleus was much harder than NASA had expected. As reported by Universe Today, Swift scientists have seen a quick and dramatic rise in ultraviolet light, evidence that the Deep Impact probe struck a hard surface, as opposed to a softer, snowy surface. In 2011, when the Tempel 1 nucleus was re-imaged, scientists had to explain why the crater left by the projectile was much smaller than predicted. The Deep Impact team then made the extraordinary claim that ejecta exploding off of the comet somehow fell back down and refilled the crater in the near zero gravity environment of the comet. as reported by Space.com at the time. Kepler 1's man-made crater partially healed itself as the ejecta settled and refilled part of the depression. Like every other comet nucleus imaged to date, Kepler 1 appeared desiccated and rocky, nor did the projectile produce the expected release of theoretical subsurface water on the comet. As noted by astronomer Charles Key in 2005, the material that came out was a surprise to scientists. A cloud of fine powdery material emerged, not the water, ice, and dirt that were expected. Nor did close-up images of the nucleus reveal the theoretical vents from which comet jets are supposed to emanate. As reported in the journal Icarus in 2007 by P.C. Thomas et al., it has proven difficult to identify specific landforms that can be identified as the vents discussed for many decades in classical comet literature, as it is difficult to locate them on Borrelly and Wild too. Nevertheless, when we fast forward to 2014, scientists with the European Space Agency's Rosetta mission to Comet 67P appeared to offer no meaningful revisions of comet theory, even in the face of all previous surprises. The mission to land a probe on a comet nucleus was based on the notion of comets as icy, snowy accretions left over from the solar system's formation. The major surprises for investigators began long before the Rosetta spacecraft reached the comet. One early puzzling detail was the comet's double-lobed shape, a mystery also found on several other imaged nuclei. Eventually, Rosetta scientists settled on the hypothesis that the comet's strange form resulted from two comets improbably colliding in a vast region of space, then somehow sticking together rather than disintegrating. But as we noted in many Space News episodes, the double-lobed form is important from an electrical perspective. As electrical engineers have always known, peanut-shaped spherules are common products of electrical discharges, as seen in this example by physicist C.J. Ransom, compared side by side with Comet 67P. As the probe drew closer, the comet's complex, desiccated, rubble-strewn terrain, which was, in the words of one Rosetta investigator, quote, dry like hell, drew increasing expressions of amazement from scientists around the world. The amazement was understandable given the complete refutation of the standard predictions for the comet's form. Consider this side-by-side comparison of images revealing the failure of comet theory over the years. On the left is an artist's rendition of the expected appearance of Comet Halley before the mission to Halley in 1986. We see a smooth, snowy surface, exactly what one expects if comets are icy accretions, whose dramatic displays result from sublimation of ices. In the middle, we see a slightly modified artistic rendition, forged leading up to the Rosetta mission. A surface that is still covered with snow and ice, but modified to reflect the completely unexpected images of dry, rocky, and complex comet nuclei. On the right, we see the actual nucleus of Comet 67P, as imaged by the Rosetta mission. It wasn't just the dryness of 67P's terrain that startled mission scientists. Closer and closer images revealed greater mysteries, as the topography of the nucleus revealed numerous planetary features. Explicit prediction of the electric universe, including mesas, rubble and large boulders, cliffs, sharp edges, wind-streaked rocks, and incredibly, even sand dunes. There was also stratification of material and evidence of complex geological
you see me on a
variants.
cruise ship wearing
If comets
floaties,
were
winging,
electrically
those little
excavated
wing
from
leash
planets
for
and
kids,
moons, as proposed by the chief principals of the Thunderbolts project, all of the observed features are to be expected. Consider again this side-by-side comparison of a region of the 67P nucleus and the Sawtooth Mountains on Earth. The electric comet model also predicts that comet activity is generally driven by the comet experiencing voltage spikes when it moves from the relatively negatively charged outer regions of the solar system toward the sun's more positively charged domain. This perspective predicts and explains many of the Rosetta findings, including the, quote, surprising discovery of fast-moving electrons and electric fields very close to the comet nucleus, as well as the discovery of negatively charged, fluffy dust grains lofted from the nucleus. Electrical discharge activity on the comet also explains the formation of sand dunes and other unexpectedly dynamic changes on the comet's surface. As we explained in several Space News episodes, The initial observation of sand dunes was met with complete disbelief by scientists around the world. As blogger Emily Lakdawala wrote, other features are odd because they look familiar and yet have no right being on a comet. I've called them rhythmic ridges, but to pretty much everyone who looks at them, they look like sand dunes, which are just plain impossible on a body that has neither atmosphere nor much of any gravity. In multiple Space News episodes, we presented experimental footage, as shown here by researcher Billy Elberton, showing that sand dunes are easily created by electric fields which produce ionic winds and organized dust material. In fact, the scientific mainstream has finally begun recognizing the electrical cause of dust-raising events on comets and other solar system bodies. In a 2016 NASA-funded study, the researchers suggest an electrostatic mechanism for dust transport on many bodies, including the moon, asteroids, and comets. A Phys.org report on the study stated that, quote, electrostatic processes may be responsible for the Rosetta detection of fluffy dust particles released from the surface of Comet 67P. But when considering the nature and origins of comets, one pathway that comet investigators must be willing to explore is the explanation of comet water production by electrochemical means. In recent years, Dr. Franklin Anariba, a specialist in electrochemistry at Singapore University of Technology and Design, has been presenting his thesis at annual Thunderbolts conferences. In a 5-part Space News presentation in 2015, Dr. Anariba proposed that a process of electron stripping releases O2, OH, and other chemical species into the cometary coma. The discovery of an electron density in the vicinity of the 67P nucleus is important. It can mean that the chemical O2 can absorb a negative charge through charge exchange, which is then followed by a process called protonation via solar wind at the comet. Water formation can then be explained via a series of pathways, as Dr. Anariba has outlined. This explanation, never pursued by comet investigators in the scientific mainstream, could eliminate the need for any imaginary reservoir of subsurface comet water ice, and it explains many comet mysteries, including the amazing desiccation of comet nuclei and the overabundance of so-called water production found in many cometary comas. It was a puzzle to 67P investigators why the comet was already producing an abundance of water and surprisingly rich molecules, even while hundreds of millions of kilometers from the sun. But recent scientific papers may be moving the investigations in the right direction. A major shock for scientists on Earth was the detection of abundant molecular oxygen and so-called outgassing from the 67P nucleus. If comets are really leftovers from the solar system's formation, scientists had long excluded any possibility of molecular oxygen being trapped in these so-called primordial bodies. As reported in India's national magazine, Frontline, the detection of O2 was unexpected. All the primordial oxygen molecules, which would have been there in a comet's evolution around 4.6 billion years ago, should have disappeared by now. Rosetta's discovery of O2 and 67P CG is an astrophysical enigma. In a paper published in the journal Nature Communications, scientists Yao and Giapis essentially proposed that water molecules coming off the comet become electrically charged. Then the solar wind accelerates the charged molecules back to the comet's surface. There they pick up an oxygen atom from the surface from materials such as sand, forming the detected O2. As investigator Giapis stated, we had no idea when we built our laboratory setups that they would end up applying to the astrophysics of comets. The original chemistry mechanism is based on the seldom considered class of Elie-Rideal reactions, which occurs when fast-moving molecules, water in this case, collide with surfaces and extract atoms residing there, forming new molecules. All necessary conditions for such reactions exist on Comet 67P. However, even with the dirty snowball theory now, in the words of Nicholas Thomas, blown out of the water, scientists continue to assume that comets are primordial icy bodies that formed over 4.5 billion years ago. Following this brief summary of comet missions, in our next episode, we will explore many landmark comet discoveries, all of which seem to affirm the electrical nature and origins of comets. For continuous updates on space news from the electric universe, stay tuned to
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In part one of this presentation, Thunderbolt's colleague Garrett Hill introduced his experimental research into the electrical scarring of planets and moons. Within a growing community of investigators, a conceptual foundation has been laid for an entirely new understanding of planetary geology. Electrical processes have been shown to routinely reproduce almost every familiar geological feature. Today, Garrett Hill continues his discussion of his research. We begin with an examination of the electrical significance of the scalloped-edged features seen on many planetary bodies.
It seemed as though that the scalloped edges would occur more prominently where there was a larger concentration of particulate matter in a given zone, and plasma filaments would strike at that particular region and sort of excavate material. When it was relatively small amount of material, it didn't seem like it would produce it as prominently as it does with more material. Different types of scallops, different distances in between scallop lines or sort of successions of scallops from a discharge that would strike multiple times as it was traveling past a certain region of the acrylic plate. It seemed like there was just simply excavation going on whenever a discharge would happen in that particular region. And it was pretty interesting. There was a lot more photos of different scallops and different looking than what these two experiments show. But it's clear that it's just a really common part of this type of experimentation is the scalloped edge.
In recent years, the electrical nature of dust devils on our own Earth and the planet Mars has become increasingly evident to investigating scientists. Garrett explains the results of his attempts to reproduce dust devil features in laboratory experiments.
When the conductor that I'm carrying in my hand gets in close proximity to the center of the mound, you would see these lateral discharges between the center of the mound and the outer perimeter of the insulator. And so these strikes, these plasma arc strikes. And in conjunction with that, you would see the development of these radial patterns as well, which were pretty much perpendicular for the most part to the lateral discharges. And so depending on the concentration of the particulate matter in that particular region, you would get these sort of diffuse marks that would be carved out of the particulate matter on the surface of that plate. And I inverted it. I was looking at the photos of these trails and I was like, wow, that looks very similar to the dust devil tracks, but the colors are wrong, right? On the surface of Mars, you have dark regions that outline the tracks. Well, here it was the light regions because it was oxidizing and moving the material out of the way and creating these trails.
The planet Venus is remarkable for its surface that is nearly blanketed with filamentary scars, known in electrical terms as Lichtenberg figures. Garrett notes how perfectly these features are reproduced through electrical discharges.
Looked at this experiment in the above slides, the perpendicular discharge patterns. You have radial and lateral distribution of these paths carved out of the soot mound and into the surface of the acrylic. We see a lot of that on the surface of Venus, while it's also adhering to sort of a fluid dynamic pattern, whether it's sort of a radial distribution of these patterns around large craters or in different regions of the planet's surface. It's littered throughout the surface of Venus. And I'm not necessarily saying that these patterns look exactly like the Oda region patterns, but the fact that there are perpendicular discharges happening, I find really interesting. When you look at those videos of those experiments with the Tesla coil, the acrylic plate, and the soot mound, you'll see that before I bring the conductor up close enough for a discharge to happen, you see the radial patterns develop first and foremost, and then discharges start happening which are perpendicular to those patterns. And so you get this perpendicular relationship and distribution of these electrical discharges, which may in a large part be able to explain a lot of these patterns that interfere with each other.
Planetary scientists believe the surface of Venus has more volcanoes than any other planet in the solar system, and they think that volcanism played a major part in shaping the planet's surface. But like the towering Olympus Mons on Mars, many of these features may not be volcanoes at all, but the scars left by powerful electrical discharges.
Just came across this photo as I was archiving the different large features on Venus, and came across a color image, and I was like, okay, that's awesome. But then when I saw the black and white image, I was like, okay, this helps relate the color and removes the interference of the color in trying to find similarities in a pattern. And so experiment 2, as you see in the video, has both radial and lateral distribution of filaments that are scarring the surface of that plate. And they seem to sort of carve out thicker regions and really
Okay, I'm in a little bit more of the advanced stuff at this rate. So I'm going to move down the list here. It's not really a request, but I noticed that a lot of people still haven't really got the fundamentals yet of this, because and it's really not that confusing. All you need is a couple, of these videos to understand what it is they're trying to convey, and then you can spend a little more time going on their papers and in research and stuff later. So I mean, if you're interested, like I was, as soon as I saw it, I became addicted to the new knowledge here. And it's not like some old crazy kookiness, this is all actual regular physics. It's just finally being applied properly. And that's what's awesome about it. So let's get this going. I think the first thing would be about the sun that you might want to know. Let's see if I can find a good one. Which is weird because they're only giving me 200 videos here. That's not right. There's much more than that in their playlist. So I guess to get those videos, there might be another route to the entire playlist. That's future science. Whoops, I just jumped ahead of myself, but I think I got the right idea here. Get it from here. No, that's not it. Even though that is it, but it's not it. Try this link, see what happens next to it. Instead of using their automatic player, go to their playlist. There we go. $200. Now we've got more than 200. Here we go. It's like these videos are hidden. Testing the electric sun. All right, fun stuff.
A new scientific study could radically change our view of the sun. It seems that the sun is not behaving as it should. Scientists have recently created what they call an MRI of the sun's interior plasma motions. For decades, solar physicists have believed that at the sun's core is a superheated thermonuclear reaction. This theory requires a massive transport of thermal energy to the sun's surface through convection. But the results of this study indicate a virtual absence of convection,
just 1% of what a thermonuclear core would require. How does this affect our understanding of the sun?
The thermonuclear model requires several things to be going on, which don't appear to be going on. One is there's supposed to be a radiative zone inside the sun, and then above that, a convective zone. And of course, the radiative zone is purely speculative. It's only required by the model. There's no evidence for it. And the convective zone is also speculative, based on the granulation that's seen on the surface of the sun. That was interpreted as being the tops of convection cells. But the fact that they've discovered very little convection means that both the theory of the granulation, the theory of the generation of magnetic field, and the theory of transfer of energy from the centre of the sun, all of these are in peril. And I would say that what we're seeing is the demise of the standard model of the sun.
The absence of the expected convection is just the latest in a long string of surprises for solar physicists.
There are many anomalies. In fact, the very magnetic fields above the sun and the very hot corona, none of these have been properly explained. There's been a lot of arm waving about energy is somehow transferred from inside the sun to the outside without affecting the photosphere, because this is what's required. But this is a really weird kind of model where you've got 16 million degrees on one side of the photosphere and tens of millions of degrees up in the corona. And sitting in the middle is a 5,000 to 6,000 degree photosphere. And it's required very sort of extreme speculation as to how you would ever get that energy out of the sun. And there's been no satisfactory answer.
Thornhill points to a different model of the sun, which relies on the principles of plasma physics.
Well, the electric sun is energy received from outside the sun in the form of an electric current lighting up the ionosphere of a body, which is no different to any of the other bodies in the solar system, only it may be much larger. And so we're looking at the top of the very top of the atmosphere, like the ionosphere of a body like, say, Jupiter or Saturn. Because of the electrical energy coming in, it's lighting up like any of the new gas discharge electric lights that you see in car headlights and so on. So that's what we're looking at, it's just an electric light. I think the theorists have to begin to look at plasma physics, the real plasma physics, the physics of electrical discharges in low pressure gases, and forget about thermonuclear models at this stage, but concentrate on plasma discharge phenomena.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Hold on a second. Since I'm playing in this way, they're not going to go auto.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In this special abbreviated edition, we flash back to January 2005, when something remarkable happened on the Sun. Over a period of 5 days, 4 powerful solar flares erupted from sunspot 720, followed by a coronal mass ejection that achieved velocities incomparably greater than anything astronomers had seen before. While it usually takes more than 24 hours for the charged particles of a solar outburst to reach the Earth, this one was a profound exception. Just 30 minutes after the explosion, Earth, some 96 million miles from the Sun, was immersed in what NASA scientists called the most intense proton storm in decades. Shortly thereafter, a
Video
NASA news
missing.
release stated that the event has shaken the foundations of space weather theory. How could the material from a coronal mass ejection achieve such unthinkable velocity? In fact, even the more standard acceleration of CME charged particles away from the Sun remains unexplained by solar physicists, a problem that only underscores the mystery surrounding the 2005 eruption. Based on the sunspot's location, one astrophysicist noted that the storm's path followed the lines of force of the Sun's magnetic field, leading directly to Earth. A NASA headline described this connection as a superhighway for protons leading all the way from sunspot 720 to our planet. However, this same article concluded how they were accelerated remains a mystery. But proponents of the electric universe insist that the event in question is not mysterious at all. Many decades ago, plasma physicist Hannes Alfvén documented the phenomenon called field-aligned currents, in which electric currents move efficiently following the direction of induced magnetic fields. Throughout the universe, across the entire electromagnetic spectrum, we see plasma jets and ejected material often attaining velocities approaching the speed of light. In electrical terms, the explanation seems obvious. Electric fields in space accelerate charged particles. Only electric fields are known to accelerate charged particles to these extreme velocities. In the electric model of the Sun, as illuminated by Professor Don Scott, the surface of the Sun acts in the fashion of a transistor, such that small changes in electric current can produce large variables in the Sun's behavior. All such interpretation requires that the Sun stand at the center of an electric field. This would mean that all of the planets and moons within the Sun's electric domain are swimming in electric currents. From the Earth's own blue sprites and red jets blasting into space, to the electrified dust devils and global dust storms on Mars, to the hot poles and electrified geysers of Saturn's moon Enceladus, and even the explosive activities of comets in response to solar outbursts, and much, much more. As we continue our discussion of the electric sun and the electric universe theory, we seek to shed new light on the countless mysteries that may finally only be resolved by a reconsideration of the role of electricity in space. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. According to a new report, the latest data from the NASA space probe Voyager 1 has left scientists without a working model for the outer solar system. NASA scientists recently concluded that Voyager 1 may have reached the outer boundary of the solar system called the heliopause. However, the scientists were met with a surprising discovery. The solar wind surrounding the spacecraft had come to an inexplicable standstill.
Hey, Deb.
Oh, hi.
Sorry, I had you hidden from the broadcast. I forgot I used that cameraman application.
Oh, yeah. Yeah, this is a really incredible interpretation of a new interpretation of how to reposition everything within the atom based on charge. So it's an electric, sort of an electric universe version of an atom model, but it's so far. I mean, there's a lot of work ahead of them in order to prove it for every element, but they've already proved it for many elements that it actually explains their behavior better. So I could try to play this episode. It's like a half hour long or so.
Yeah, this is the shit that we remember how we used to talk 4 years ago.
Oh yeah.
However long it was. Seems like it's been a while, huh?
Well, I knew that there were many people working on different versions of how to better structure the atom because the old models just don't explain very much. They're not very explanatory.
It really makes you think. As a kid, I was really on. A lot of different kids do this. I'm sure. I can't be the only one. You take the model of the solar system and then make a model of an atom out of the same project. You know, you have two different projects out of the same one. And that connection was made for me on my own years ago, and it was, and I never understood gravity as their gravity. I always thought of it as, you know, some sort of an electric field.
Right. The best way to think of it is think of those little ball magnets and the different ways that you can put them together. That's exactly, if you look at what he's done, he got his ideas originally from that. And it's very, what you end up with, things have to be structured in a very specific way. It's so cool. Yeah. Let me see if I can set this darn thing up. I hope my system cooperates with me. That's all I can say. Tell me when you can see my screen.
Oh, now we got it. Now we have you.
Okay, this is it right here.
And I will present you to everyone.
Let me pause it first and get it up there. Okay, let me try it now.
Thank you. Good afternoon, everyone.
Adjust that volume a little bit.
Believe it or not, I've got it at max right now. Can you even hear that?
Well, yeah, go to push pause for a second. Go to your what do you call it? Your with your mouse, move it over to your volumes button, and
try that right now.
Click on it and hit recording devices. With your left click, go to the microphone you're using, double left click it. Go over to the levels tab.
Hold on a second. Which one am I in? A playback?
You're in the microphone. Go to the microphone.
I'm in there. Go to the
yeah, go put your mouse over the microphone.
But is it on the playback or recording?
Recording. You're in the correct one.
Okay.
Go down to the microphone. Yep, that's the microphone. Double click on it with the left side. Okay, go to the levels tab where it says levels above. Right there. And now turn it up. There you go.
Okay.
That's it.
Okay, for the nucleus, but instead
Did it better?
of mathematics to express the atom in its non-deterministic nature. Is it possible that there is a structure to the nucleus of the atom?
Occasionally check it and see if it's still on there.
If I do, it's going to show on the screen.
Precisely that attempt. We show you how this structure, with its particular rules and mechanics, are responsible for the periodicity and the groupings of the periodic table of the elements.
Let's see if
My goal today is to take you from this two-dimensional solar system model of the atom with no structuring whatsoever, as we can see on this side. And I want to take you to a logical three-dimensional structure of the atom. The proton electron found in about 1933 has been taken as a base for that. Now, before I continue, I would like to draw everybody's attention to the disclaimer of this presentation. We are all agreed that your theory is crazy. The question which divides us is whether it's crazy enough to have a chance of being correct. Use your presentation is made up of the following: the current understanding of the model. So we'll take you through a short history lesson there. And then we will go into the true proposal for the structured atom model. And the third part will be to touch upon some implications of this model. in the end we will conclude. Our journey begins in the early 1800s when John Dalton was doing his research. Dalton used the relative atomic weight and published a table of the relative atomic weight, so we have the first rudimentary form of the periodic table of the elements. For example, Dalton found that 12 grams of carbon could react with 16 grams of oxygen to form the compound we now call carbon monoxide, or with 32 grams of oxygen to form carbon dioxide. The ratio of oxygen masses 32 to 16, which simplifies 2 to 1. At some point, it was discovered that certain elements have common properties and that there was a periodicity to the elements. In 1864, John Newlands described the law of octaves.
I can barely hear you.
I know. I don't know why it's so low on the playback.
Elements such as germanium. This
Let me
concept,
see
however,
if,
was not recognized.
Oh, maybe you need also
Okay.
left click on your sound button this time, and then hit.
After becoming a teacher in 18, Mendele wrote a definitive text of his
You're
time.
saying mute inside the lock hangout?
1870.
Where you started to go last time, the very first click, instead of yeah, there you go.
To classify the elements according to
What
the
should I
chemical
do?
properties, he noticed patterns that led him to postulate his periodic table. Mendeleev claimed to have envisioned the complete arrangement of the
Are you
elements.
saying,
One of the volumes.
I saw in a dream
okay,
table
the
where all
others,
the
these
elements
shouldn't
go
be
into places
affected,
required.
but
Oh, okay.
this one,
Immediately wrote it down on a piece of paper. Only in one place
I'm not
did a
sure.
correction later need seem necessary. So I would like to point out here, which is his periodic table, the purple elements like helium, neon, argon, krypton, etc. They were totally opposite.
That's not it.
And here we see, for example, the germanium.
what?
By looking at
Am I in
these
the wrong one?
response, we were able to
No, that's probably fine. You're, it's not playing loud on your speaker.
Thomson performed his cathode ray experiment in
Okay,
1897.
is there something you want me to do?
Oh, I didn't know if there was anything we could do.
I think we've maxed out on everything, yeah. I don't know why it's so low. Yeah.
The current flow can be observed, suggesting that the atoms have been broken down into
He's
charges.
just going through the history right now.
I can hear it.
Is a heated cathode, in fact, causes the atoms to sample to ionize. These were known as cathode rays at the time. In 1897, Thomson set out to prove that the cathode rays produced from the cathode were a stream of negatively charged particles called electrons. For Maxwell's theory, he knew that the charged particles could be deflected in a magnetic field, which is shown just about here. So, depending on the polarity, the electrons went up, down. Because of the bending of that path of the emitted electron in the cathode tube experiment, it became clear that it had to be a charged particle. Negative in nature because it was pushed from the north-south magnetic field that has been put into the electron beam path. Through his work, science was introduced to a whole new discovery, namely the electron.
Can I ask you a question?
The result was a model for the atom that acknowledged.
Yeah, Graham?
Okay. Now is he still basing his theory on particle physics?
Okay, say again. Is he still what?
Turn your shit. Sorry, it's so much work. Turn your shit down because it's not going while I'm talking, but that's too much work. Is he still basing his theory on particle physics?
Not exactly.
Okay, 'cause it seems like he is, and I'm like,
No.
I said it was like the edges of a coin. and that would be the positives and the negatives. You would see that, and what they're counting as, you know, electrons are just the peak of those waves. They're the peaks, the inverse, and the out. You know.
No, it's because of the way he's only going through the history here right now of what have come before. But
oh no, I know. That's why I asked, because he's taken a pretty long time to get to his part of it. So I was asking, is he going to, you know, to try and use particle physics, or is he gonna, you know what I mean, talk about it as a wave or as a standing, you know, field structure?
He's going to show his models from a particle perspective, but the alignment's based on charge, and that's waves, that's fields, and so that's where it gets interesting. Okay.
Well, see what I mean, though. What I'm saying, like the whole thing is the structured field, and the point is what is he's thinking are the positive and negative flows of charge. You know what I mean? And they're really the way the wave ripples. It's like going like that, so it looks like it's flowing that way. Because each time, because the point of the wave just moves like this. If you're looking at the point of the wave, it looks like a dot going around in a circle. But if you look at it as the wave, it's the whole thing is moving like the snake, right? And you know what I'm trying to say?
Okay, what you will see is that the orientation step with the unusual angles that create lattice structure can only be done in a field, a charge field. Okay, so in essence, what he comes up with, you have to look at it as a field, not as particles. But you'll see that when you see his models. Okay.
Here's what my idea. I'm drawing it real simply, real quick. A simple one, right? And then it would probably be the same thing going on inside of it too. It would be, these would be the points that they would be calling the positive charge. These would be the points that they would be calling the negative charge. And then inverse to that backwards and inside of it, if that's something. I mean, extra mechanism there. I got a better idea. Right now, when you look at it the way I draw it, right, it's moving like this, right? But they're only seeing this part of it move.
No, yeah, I understand.
It's going like this. To them, those are the orbit to them. So it's just I'm laying my idea right into theirs, right into it, and it's still working. You see what I'm saying? There's their orbits. There's like this. That's what they're tracking. They're tracking the peaks of these things, because that's the point that registers a positive charge. And then here's where it registers the opposite, when it's down in this side, when it's doing its flow, opposite. So really, there's not as many pieces as you think. It's really less pieces doing the same thing. And then here is probably a transmission to the inner side, some, through the magnetism, you know, and it creates the whole thing again on the inside. Whatever structure it could possibly make with the symmetry available or the room available in the, you know, between the two charge or whatever.
On what you're drawing, you may find that what he comes up with could have been gotten to that point by understanding the process that you just described. What he shows, though, is the final setup as a result of being in a field, a charged field. And the key to what he does is he looks at he no longer looks at neutrons. Neutrons are basically, just look at them as protons and electrons. And by doing that and understanding the field that they're in, you realize that some of them are not even inside the nucleus. Some of them are, or some of the electrons that were previously outside the nucleus become inside.
That's what I do. There is no neutrons. That's just the magnetism.
Yeah. Well,
that's
it was
magnetism that they thought, it's like that's the empty space that's making up the material.
Well, came up with the idea of neutrons to account for supposed mass and also the fact that there was more in there than could account for just so many positive charges. The moment that they did that, okay, they had to invent things like gluons and all this other nonsense to try to hold it all together. And what he comes up with doesn't require any of that. The field and the alignments explain everything. And that was another thing that was very fascinating to me. No more force particles, okay?
Yeah, it feels like common sense to me.
Yeah, exactly.
It's like, it doesn't feel like there should be any such thing as a force particle.
What he did,
a particle in itself doesn't make sense. Magnetism is stronger than a particle.
What he came up with better explains what happens then if you look at these atoms in this way, and then now you want to try to understand, why do chemical bonds to these atoms form in a specific way? He can explain those bonds better. That's what really fascinated me. So you got to watch the rest of this, even if the hearing is hard, because you'll see what I'm talking about.
Yeah, let me mute.
Okay, I'm going to mute myself too, so I won't be able to talk to you, but I think you'll get the sound better if I do. Okay.
No, it doesn't work that way. It has to play over your speakers. Unless you align it into the stream it to the Hangout. Can you hear me?
I was playing it over my speaker.
For some reason, it wasn't working.
Oh, I'm sorry. Okay, maybe it's because I can't. I was muted. Okay, sorry. Yeah, that's not gonna work. Okay.
Yeah.
Try it again.
He was in the end honored with the Nobel Prize in Physics in 1906. When Chadwick famously discovered the neutron, it caused a debate that was finally more or less settled at the Seventh Solvay Conference in Brussels, Belgium in 1933. The only alternative to neutrons was the existence of nuclear electrons, which would counteract some of the proton charges of the nucleus. Since by then it was known that the nuclei had about twice the mass that could be accounted for if they were simply assembled from hydrogen nuclei, meaning protons. But how these nuclear electrons could be trapped in the nucleus was still a mystery. This is when and where it was decided at the Solvay conference that the neutron is not a combination of a proton and an electron, but rather a fundamental particle without an electrostatic charge, meaning it is neutral, hence the name neutron. after the acceptance of the neutron, which was very much influenced by the need to make quantum mechanics work, we basically end up with our current understanding, in essence at least, of the atom. I quote, an atom has several key attributes that are observed. A positively charged nucleus. The nucleus is depicted here. The nucleus is made up of positive protons and neutral neutrons. The red and the green, if you will. Red. Green. The electrons do, however, not fall into the nucleus. It's still a little bit of a mystery. And the ratio of the neutrons, protons, and the outer electrons on average is 1 on 1 on 1. Note that the current nuclear physics explains the nucleus in quantum mechanical terms. In the nucleus occupying a certain energetic state, each nucleon is said to occupy a range of locations. To refresh everybody's mind here is what the current periodic table of the elements looks like. We see there is a periodicity in groupings in the list of elements. The periodicity goes from the left to the right, and the groupings go from top to bottom. The term element is used for atoms with a given number of protons, regardless of whether or not they are ionized or chemically bonded, for example, hydrogen and water. In short, the number of protons and the outer electrons determines the element. When all this is taken into account, the current understanding of the atoms and the elements is very poor, to say the least. This is all that is offered after a century of research and untold amounts of resources. Having been poured into technological projects based on this, then I would feel disappointed in fact. This is what drove me to study the atom and the elements. The disappointment of, in truth, a highly disputable model that asked us to believe certain things, in order to make it work, would simply not satisfy my need to know. Throughout the years, my personal lesson was that the whole basics was wrong. This started for me at around 2006, and ever since the model has been slowly growing and maturing. The strong force, which is seen at the first bullet point, is a postulated force. It simply was needed in order to explain how the protons would stick together in the nucleus. So, any good model should be based on observations and logic. Only after that comes the understanding of the whole, or the narrative, if you will. The structured atom model has the following key features. It shows a logical construction of the atom in accordance with observations. It explains why the atom has a positive nucleus with negative electrons around it. It explains why the electrons do not fall into the positive nucleus. It explains in a logical manner how chemistry arises. It explains the periodicity of the periodic table of the elements. And still an open question, why do electrons and protons not annihilate each other? Still unanswered. SAM is a new model. No, yes, take your pick. Let's see. This model is still very much in development, and despite some efforts to the question as to why the proton and the electron do not annihilate each other, still unanswered. The only thing I would like to add is that the observation would indicate that perhaps the proton and the electron are made up of smaller organizations. The model right now does not rule this out nor deny it. In fact, I think this is a beautiful example of how we can cooperate from different.
It's some techno is playing in the background, right? This model is very, very strange to you. It's going to be new and different. You're going to love it.
An organism, the nucleus of the atom. There's simply too many hints and leads that cannot be ignored. That point out the point to this to be true. when we try to find an answer to how the nucleus of the atom is organized, we can find no real answers at all. Only that the nucleus is made up of neutrons and protons. How these fit together is officially still a mystery. This presentation will offer evidence that the nucleus is structured. I will point out how this is the case with its regularities and rules and what principles are in effect. At about 2008, I found a correlation of the geometry of spheres. It's called spherical geometry. You'll be surprised how little can be found on that. When we reach the number 7, we reach lithium. It's called a pentagonal bipyramid with a fancy word. And in 2010, I understood the carbon corresponded with the icosahedron, or rather 12 spheres. In 2012, I found basically an entire structure of the nucleus and how it functions. Ever since, I have been a student myself of this model, and I can find correlation after correlation. Some of these I hope to share with you here. The model, in short, comes down to this. We have a duality, which is depicted here on this slide, that we call a proton-electron pair that has an electrostatic force acting between them. This force is the causal factor for the principle of the densest packing that creates geometric shapes. These geometric shapes are integrated in a specific ordinal number, and they create all the elements. During the next slides, I will try to show you how that is the case. So when we go into the structure of the atom model, I would like to point out these postulations/observations that the model is based upon. There's only one fundamental force, the electrostatic force. The atom must have a definitive organization which is responsible for all the attributes of a particular element. The neutron is not a fundamental particle. It's a composite of a proton and electron, but it's redefined as a connection between a nuclear electron and its surrounding protons. The stable element must have a stable nucleus, i.e. there can be no movement without any cause in the structure of the nucleus. A sphere, or a proton, must always be part of one of the 3 identified geometrical structures, namely the tetrahedron, the pentagonal bipyramid, or the icosahedron. The depictions will come in a little bit. And the inner structure of the atom, the nucleus, dictates the outer electron structures, or rather the orbitals. So when we reach the new neutron, this is a schematic view on it.
Drawing my model. Remember my model? That's it. I drew that for you one night, remember? I took quarters and I sat there and I just traced the quarters and...
Well, you'll see that what you were drawing actually was a specific model of carbon.
Was it?
Okay, hold on, just watch it. Okay. Hold on.
It's a stable structure. The charge of the electron in the center is divided over the protons. This binds the protons into a rigid connection, if you will. It resembles the nucleus in a stable configuration. The second electron, to make the whole neutral again, is simply booted out. It's placed in orbit, which is about 100,000 times the radius of the nucleus. On the left, we can see schematically how the free neutron decay occurs. Now, at the bottom, we can see an intimately connected proton and electron, meaning there is no more energy in that system. It does decay, however, into the top prediction of basically a hydrogen atom, the proton and electron at a distance. On the bottom right, we can see what happens when we go into a triangular configuration which is depicted by helium-3. There's simply no room for more than one nuclear electron. They're too close to each other. The other two, which are depicted in green here, are simply put out again. But to balance the whole being 3 protons, and 3 electrons. Above that, we see how we end up with a helium-3 with only one nuclear electron taking its resting position in the center of the 3 protons, or at least it is seeking out that point. So in classical terms, we are left with only one neutron, 2 protons, and 2 outer electrons. I would like to point out a paper done by Carl Johnson, actually more than one paper. It's called The Statistical Analysis of Isotope Analysis. This analysis of the precise NIST data seems to indicate that there is no energy which exists within any atomic nuclei to account for the existence of any pi mesons or the necessary binding energy of any neutrons, or of any ultra-powerful strong force, or any neutrinos for that matter. The research has resulted in a far yes, in a far simpler and more logical description of the atomic nuclei. It also entirely complies with the known laws of science. No unseen strong nuclear force which allegedly works at an imperfect power distance, except then it also reverses in effect at really short dimensions. It is either necessary or represented by any energy source. I would like to invite everybody that is very interested in this topic to try and seek out those papers. Quite profound. Here we see the building blocks of the model. From left to right, we can identify them. Here we see the platonic solids, excuse me, the platonic solids. This is on the bottom here, we see the spherical geometry. The spherical geometry is not like the so-called Pauli geometry, which uses points and lines in a two-dimensional depiction. How the platonic shapes are actually created by using spheres. And as Plato already said, the atoms must be made up of geometrical shapes. This picture here was taken last year at the Perp, sitting at the Grand Canyon.
That's exactly what I see floating around in my model in my brain when I'm drawing that two-dimensional shit.
By creating software code that led to a three-dimensional atom builder, we can actually recreate on the computer the elements. The picture you see here the pictures you will see during this presentation are taken from that particular atom builder. The model has already been proven to be crucial for further continuation. On the left, we see the basic building blocks. First one would be hydrogen, the second one would be deuterium, third one would be helium-3, fourth helium. This one is the so-called pentagonal bipyramid, which equates to lithium, the first true element that we have in the periodic table. Even the name implies this, because lithium meaning stone, stone-like. And the last one represents carbon. Here we see, here we see some essential tools in the college that we use to develop the model. Nothing fancy, nothing expensive. Magnets that you can see on the bottom here are used as a valuable tool because they mimic the central attraction force that is also available, also there in the atomic nucleus. This beautiful mimicry of densest packing, or rather the electrostatic force. Treated properly, they will show you the correct structure of the elements. Everybody can do it. Here we see the platonic solids again, created using spheres, the so-called spherical geometry. Take note that the cube and the dodecahedron are not stable. They can easily be distorted. in contrast to the other three. Cube is not stable. The tetrahedron is stable. The icosahedron is stable. Dodecahedron is not stable. The octahedron is stable. The proton geometrical structure cannot exist on its own, nor can an electron structure be on its own. They need each other. They need each other in order to be in equilibrium. Only one on its own cannot be, the other one on its own cannot be. Together, they can be, they are in equilibrium. All the protons that we have in this model must belong to three geometrical structures. As I said, the proton, the tetrahedron here, the tetrahedral bipyramid represented by lithium, and the icosahedron represented by carbon. On the left, we have the electron structures, which is an octahedron and a dodecahedron. On the bottom here, I'm trying to show how they...
Perfectly reasonable.
There is so much in this, it's incredible.
No doubt. I can't hear it anymore for some reason.
Yeah, he's...
Platonic solids, meaning there is no bigger geometrical shape that can fit into a sphere, i.e. there is no bigger geometrical structure. The combination of protons and electrons pulled towards its shared common center of that icosahedron. This is the primary argument for the applicability of the density packing principle. Carbon embodies the icosahedron with its 20 triangular facets. Right. Carbon embodies this icosahedron with its 20 triangular facets. The 20 triangles correspond to the number of electrons necessary to reach the noble gaseous state. With carbon, as is depicted here, not all the triangular facets of the nucleus are occupied, meaning there are positive spots left on the nucleus that can still react. In the green, you can see where an electron would be, and where there is no green yet, here, still the positive charge left. So on the left, we see a carbon with only 6 inner electrons. On the right, we have a carbon with the 6 inner electrons and the 6 outer electrons. However, take note, not all the spots are still green, meaning there's still chemical reactivity left. This is basically the fundamental principle as to why chemistry is happening. If we take a look at the noble gas configuration, we have the same nucleus, however, there are, like shown on the right, extra protons. These extra protons also imply there are extra electrons. In the case of neon, we get the first complete nucleus, if you will, where all the spots are occupied. Hence, we reach the noble gaseous state. It's important to notice that this icosahedron of the carbon, which is still depicted here, has 20 triangular surfaces. So we get 10 inner electrons, 10 outer electrons. Together they will occupy no more positive charge, no more negative charge, no more reactivity. Hence, again, the noble gaseous state.
That's incredible. That explains why they can't interact.
The main structure of the atom, or the backbone of the nucleus, is made up of the icosahedron, or as determined in this model, the carbon nuclet, whereby nuclet refers to the identified geometrical shapes of the protons. Each geometrical shape or nuclet has a center of attraction that is created and shared by the protons that are part of that nuclet. The geometrical structures are connected to each other by sharing a proton, shown on the first image here. The main structure of the atom is The main structure of the atom is therefore a collection of the connected carbon nucleates that adhere to a doubling mechanism. We tried to depict it in the rest of the pictures here. We go from 1 carbon nucleate to 2 carbon nucleates to 4 carbon nucleates to 8 carbon nucleates. This triangle, as you can see, it's everywhere on the nucleus of the atom. This is most important. All the proton structures will always have only triangular surface areas. This is when it is stable. This triangular area is where an electron would find its resting spot, or at least balance out and try to find that position. Here we see how the periodicity of the periodic table is a result of these geometrical shapes. Excuse me. What we see here is highlighted the carbon group in the periodic table. The carbon group belongs, carbon belongs there, silicon belongs there, germanium belongs there. When we go to the shapes, look at this picture. On the left we see carbon made up of 12 nucleons or photons. In the center we see silicon, which is 28 in total. However, on the left we see the same recurring carbon nuclide, which is where all the reactivity or the chemistry is. On the right, we see the green. Every time we see green, it resembles a neutralized spot, meaning that part of the atom, or the nucleus, does not participate anymore. Germanium is made up of 70 nucleons or protons. We can see that basically the whole atom is neutralized.
Yeah.
And again, same recurring carbon nuclide. The number still add up. So when we see in this model these numbers here, they correspond exactly to the element. Another example is the alkali metal group. So lithium, sodium, and potassium. And when we try and take a look at those shapes, we get the following picture. On the left we see lithium with 7 particles in the pentagonal bipyramid. In the center we get sodium, 23 particles. Again, the only active part of the atom is the red part here. And to the left, again, the neutralized part. On the right, potassium, 39. The whole atom is neutralized except for the lithium nuclide. The final example would be the noble gases. So we've taken neon, argon, krypton. We take a look at the shapes with the following picture. Everything is completely clean. Only neutral endings, as I call them. And we see neon with 22 in this case. Neon has 20, 21, 22 as a stable isotope. Chosen 22 here. Argon with 38 here. And krypton with 18 here. This keeps on recurring. This keeps repeating. Cycle of 8. Here we see how the periodicity of the periodic table of the elements is the result of these geometrical shapes. So the valence factor, or rather how many connections we can make with a certain element, we can see that the carbon is usually thought of to us as being a +4 or a -4. The nitrogen being a -3, the oxygen -2, the fluorine -1. We can see the number of green increasing, meaning every time that air is added, that part of the atom is neutralized. And the valence factor is dropping by 1. When we continue, we reach neon, completely neutral. Sodium, however, is +1, represented by the lithium nuclide again, as we saw in the previous example. Magnesium simply has 2 of those. Aluminum, a little bit more complex, it has a lithium nuclide of geometrical shape. And on the right side, we see the yellow, which is representing the beryllium nuclide. Just a little bit heavier than the lithium. After that comes silicon. Silicon again has +4, -4, and +2. But we see just as above the carbon nuclide, and here active carbon nuclide. The right side, the atom again is neutralized. This keeps repeating and repeating and repeating. The periodicity of the periodic table of the elements. See where we are. Right. Carbon-14, most commonly known example, I would say. Carbon-14 is radioactive and decays in approximately 5,000 years, something to that effect. And we see the density packing at work. We can see here in the center is a general depiction found on Wikipedia, for example, how an electron is booted out. Or, in this case, here, we see how a neutron decays into a proton and an electron. They also talk about neutrinos, antineutrinos, but we leave them out for a moment. On the right side, we can see here, according to the new model, we can see carbon-14. In the center, we have the same carbon nucleus that was blue just a moment ago. We have on the top one extra neutron, and on the bottom one extra neutron. Meaning it's a proton plus an electron to bind them together. When they come close, they decay. Meaning, two are together now, and there's only one electron needed, or rather, actually, there's only room for one electron. So the second electron is booted out, as we could see here. It takes its place in the orbit, therefore we reach the next element. So you could say in classical terms that the numbers are 6 protons, 6 electrons, and 8 neutrons, becoming 7 protons, 7 electrons, and 7 neutrons. That's the decay. If we talk in the new model, we actually have here 14 protons with 8 inner electrons, the 6 of the carbon plus the 2 of the loose neutrons, and the 6 outer electrons that have always been there. And it decays to the bottom simply to, again, 14 protons, 7 inner electrons, and 7 outer electrons. This is the so-called beta minus. Now, our current research still focuses very much on these structures. And we're trying to create a corresponding periodic table of the elements. Not so much that the current one is wrong, but there are some improvements to be made. Half the elements have to still have to be created in the atom builder that was mentioned before. It's quite complex because of the number of possibilities that arise due to the doubling factor. We are nature. So we are currently, for example, looking at the possibility of the existence of elements halfway the periodic table of the elements that have not yet been discovered. I'm not talking about the real heavy elements. I'm talking about elements halfway the periodic table, close to iron, close to copper, close to silver, gold, etc. Nature tends to skip these steps. Simply not so much because it cannot be done, but because the combination of two to make the fusion happen, usually we get a helium nuclei or a alpha particle which combines. An alpha particle consists of 4 of these protons. But to create that missing element in between, we need a deuterium to act on that. Just the chance-based and the abundancy of certain elements makes it almost impossible. Besides that, we are not even aware that there might be something missing. It is my belief that ultimately these elements will be either discovered or created. I hope, I think, might actually validate this model in the future. You can see here how it basically resembles a tree-like structure and where this doubling factor is coming on. So this is like a stem, which goes into another 2 branches, another 2 branches, another 4. Interesting to note, over here there's a collision. The 2 branches basically touch each other. That happens just about where the stable elements, lead and bismuth, are the most stable last elements in the periodic table. From that point on, all the elements are radioactive. I believe that due to that coming together of the branches is where it breaks. The bottom basically breaks up and the atom is split in 2. I think we all know what that leads to. This theory is still far from complete. It provides actually opportunities for everybody to participate in this advancement. There are limitations to specific fields of science due to limited understanding of the atom, I believe, in general and the elements specifically. The atoms affect just about everything. In fact, I would like to challenge the scientific community to either point out these flaws and provide the next answer or a clue or an error, or validate the proposed method. This is something I think we should all agree on. All that is presented here today can only be done, has been done without any professional support, and represents a few creative minds working together. And I can only imagine what we could achieve as a collective. We see here a screenshot basically of the atom builder that has been created. Again, James Sorensen has been most important in this. He has been able to convey the model that I had in this rudimentary form into this atom builder, and we can see here some of that. Anybody that is interested in this and learning more about this, I would like to invite to the breakout room. We have beautiful setup. We have lots of examples. We have magnets you can use and create and play with. I would like to summarize the new atomic model as follows. We have a duality that we call a proton-electron pair with the electrostatic force acting between them. This force is the causal mechanism for the principle of density pattern that creates geometrical shapes. These geometrical shapes in a specific ordered sequence and number create all the elements. The model shows the observed nature and properties of the atom and explains the reason why the nucleus of the atom is positively charged, why the outer electrons stay at range and do not fall into the nucleus, and addresses a causal fact of chemistry. In fact, physics and chemistry are kind of separated exactly where the atom is. In this case, the physical model goes straight into chemistry. And there are many, many more implications and consequences. Too many to mention today. There's some potential implications here, and I named some here. We have plasma physics, astrophysics, cosmology. I think we can reach a far better understanding of the nuclear structure. Better understanding.
Let's cut it. We need to cut it.
Hold on here.
Here we go.
So is my sound okay?
Yeah.
Okay. So what do you think about that? I mean, that is an incredible body of work. This guy has taken...
I see the idea is it's the right shapes and everything, but he's still not... I mean, I'm not saying I'm right, but I'm saying according to comply with what I'm saying, he would have to be saying that it's those little balls are all made out of the same ether. They just have a different magnetic quality to them due to their position and the, you know, in the frequency or whatnot, and you know, all of that. So it's like, it's all made out of, it's just like boom, 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 made out of the same material there. Then they behave the way they behave.
First of all, you you got me still presenting to everyone so they can't see you.
Oh.
Yeah, you want to take that off. Okay, great.
There we go.
Yeah, here's the thing. What he's done is he's shown how you can define everything with just the electrostatic force. That's incredible. Okay, I mean, in terms of quantum physics, this is an unbelievable shakeup. Okay, all right. So he's shown one force, and he's shown, looking at duality of proton and electron charge, you can create very specifically. You can show that, the funny thing is this was available to all of us on a macro scale by looking at those little ball magnets and how, when you put them together, only certain shapes were stable, right? Well, it turns out all those shapes of stability define specific elements. Incredible. Okay, now it goes further though. having developed that and better understanding that inner structure and how the outer electron structure, what remains of the electrons that are on the outside, how they have to position relative to the inside, and you develop that for each element, now you see very clearly why chemical bonds form exactly the way they do. It showed how you can only have certain faces at certain angles that can attach between one element and another. And this has been something that's been long. I mean, all they've been able to do up till now in standard physics, standard chemistry, is simply say, well, we know it can only form this way, but we don't know why. It's the electrostatic force. God darn it. I mean, we all knew.
Obviously, I think the thing is a lot of them do know it. You know, there's an actual suppression. This stuff, it's not. If a guy like me can just visualize it first and then start seeing all of these people coming up with these theories that sort of support what I've been visualizing, a guy like me, I'm a regular guy, so it's obvious. It's like being hidden. You know what I mean?
Well, and the reason why you were able to visualize it was you did one thing that people first going into the field, first learning about all this, they're bombarded with all these different forces and all these different mechanisms. You didn't look at it that way. You said, okay, there's only positive and negative. That's it.
Erased everything else.
Right. And you've got to orient yourself with all the number of charges. You've got to find a way to orient it in a stable fashion. A best fit. Best geometric fit.
And that's the negative comes neutral seclusion zones.
Well, and that's the other interesting thing that connects up with this, that there are certain areas of mathematics that gave us a clue, like the Platonic solids. It gave us a clue as to if you're only dealing with one force, a duality force, it's going to force certain orientations. We saw that in the math, okay? And then when we actually play with it, with an action, as I say, the best way to do it is with those little magnetic balls, because they already have incorporated in them that duality, that field that restricts you to forming things only in the manner in which you can form them. And to me, this is just incredible. Yeah. There's so much potential here in terms of, like he said, what this can mean for future knowledge on explaining finally what we see in nature. Like it's such as, and this in fact could help us come up with ways of explaining plasma behavior a little bit better.
Well, it's already used. That's how the anode tufts are being already studied.
Yeah.
Right now, and that's exactly how they behave in relative position to one another, of course, since each plasmoid on the anode, each plasmoid on the anode stays separate, and due to its, placement in the Birkeland current, its rotation is different.
Mm-hmm.
It's, and speed and whatnot. Like the equator spins faster, just like on the sun, than on the poles.
Well, yeah, and the way to look at plasma's behavior is always in the presence of that electric field, as you say, that electric current, because of its completely ionized state. It is more free to follow the twisted behavior of the current, okay, than something that's more cooled down in a different state of matter. All right, which is why you see this erratic behavior in plasma, in a highly sharp, where you've got a strong current going through it. Yeah,
pretty cool stuff.
It is. I went to that site that he had, structuredatom.org, but you have to have access because I wanted to start building some of the other elements. But yeah.
To me, I still see that as like wait for the next guy because he's still not seeing it. He's doing a better description of observations, but not explanation. As far, I mean.
Yeah. See here, that's what I'm trying to say.
Because if he's still working with particles, then he's still saving particle physics.
No, okay, here's the thing. He's not really, because what he's basing it on, the restricted orientations that he's coming up with, you remember what he said he used as a basis for coming up with this. He used things like little magnetized balls, which built into those balls is the field. And the field is what restricts it. So in a way,
but you gotta, he's using the balls as particles.
Well, no,
They represent particles in his theory, yes.
Okay, but he's drawing them as spheres of charge. That's what I'm saying. Built into what he comes up with is restricted by the field, okay? He's just using these balls to describe it, you know, on a piece of paper to you to see the restriction.
Yeah, but he hasn't defined a field.
But that's what I'm saying. He didn't need to because he already used the field to come up with.
Well, no, you do when you're dealing with particle physics because the field becomes little particles to make a field.
No, yeah. If your goal is to explain the chemistry, then what you're saying is,
You get what I'm saying, right? Like his theory.
I do, but I'm just trying to explain to you that in a way for what he's
I understand. I totally got it. You're not getting that. I get it, right? You do get that. I get it, like fully, except that he's still saving particle physics. That's why I have an issue, because I do get that. I can see exactly what he's doing, and he's still saving particle physics. He's not taking that leap and getting outside of the box and saying it's ether forming these
No,
spheres.
I understand. I understand completely what you're saying. What he's doing is he's trying to explain. He's saying what's inside. Can I finish? Yeah. What's inside the sphere, we're going to worry about another day. I'm going to take it from that point out. That's what he's doing. Yeah.
I know, and I'm pointing that out because he's not really saying I'm saving that for another day. He's not saying that, you know.
He's not saying it. I'm just
particles.
But that is
you are
what he's doing.
Thoughts and emotions into him that he hasn't conveyed to me. You're putting things that he might be going to say later, like he hasn't conveyed that he might be going to say later. You know what I mean?
Well, what I'm actually
like only you have, and I don't know why you're doing it.
No, what I'm actually doing is conveying what I'm thinking.
I know I know, and you're transmuting it onto what he might gonna be doing.
No, okay, please let me finish. Okay, what I see here is he's tried to start solving the puzzle of once you just accept a certain basic, how does that build out? That's great. We need that work. I too am studying the inner part. Okay, so I am frustrated too that we still are working our way through. Can we even explain this more basically? And he did admit that in the early part. He said, I'm not going to address, I forget exactly how he worded it.
I got it. I get it. What I'm trying to say is if you go and learn everything his way right now, it's going to all have to be revamped and rewashed again later when he realizes that it's not particles and it's this other thing. And that's why he has anomalous behavior in his model still and blah, blah, blah. That's what I'm trying to get at. I can see it all down the line already. He's still using particle physics. He's still not able to separate the field or define a field or do anything about a field except describe what he sees happening on a field. Not what a field is, not how the field behaves, why, you know what I mean? Why the field behaves the way it behaves, just that it does in particular situations.
Mm-hmm.
So again, you're stuck all the way back at not understanding the truth and thinking in particle physics and stuff. So when he describes it another way, because what I see is I already saw all this. Like this is all common sense to me, except for it's not particles. I'm trying to take him a step further. Like I appreciate the detail he went into proving that those shapes are what they are. But I mean, like you said, there's websites and shit that make these shapes. It's pretty easy idea. It's pretty simple symmetry and a lot of, you know what I mean? Like, so why are those shapes those shapes? He's still not saying anything. Everybody knows that they're that shapes already. I mean, that's pretty close to already how we already see everything already. That's not even, nothing's really super new what he's doing here. See what I mean? We already kind of do have those models.
We fragmented, yeah. He did tie it together into one.
Because he's keeping particle physics alive. That's the Shillman. That's how it works, Debbie. That's how you can see that. I can see through him because, I mean, to me, it irritated me. It was like nails on a chalkboard because he's taking something that he's taking so much energy to just tell us the simple, basic nothing. And he could have easily just took it a step further, like he should have, if he was going to be explaining anything brand new. It's because of this field. This is a theory, you know, it's otherwise it's still just particle physics. Let me reorganize particle physics. We already knew there's other ways harmonically to set it up to where we can see more missing elements in between. You know what I mean? So there's so many different, as far as like mathematical structures. But that might be why he's thinking there's so many more elements, because his mathematical structures are of particles and not of the actual fucking thing that I drew that moves and looks like a bunch of different particles. You can only see the peaks of them moving, where the plasmoids are the densest.
Mm-hmm.
Get it? What I'm saying?
No, yeah. What you're doing and what other physicists are doing right now as well is trying to explain at the ether level what's going on, which you have to work only in waves and fields. That's it. That's where that comes in. And I've been studying that too, as you know. But I will say this, what he came up with was a better model of chemistry, of bonding, okay, to explain why bonds occur only in a specific way by using only one force. And that is a better model for chemistry. And that's what I saw that as. That was the biggest thing that he could help better explain. But working on the chemistry level is ignoring what goes on underneath that level. You're taking certain aspects of the substructure and you're simply saying, at the surface it has these properties. But how did it get those properties at the surface?
But that's what I'm trying to say too.
That's where the ether comes in, and that's a whole different study. Yeah.
Yeah, but he needs to realize, right, the reason that electron is orbiting the structure and is kicked out of the structure is because there's a background,
yes,
always present inside of the field. It's like a wall, background wall, something you can build off of. The dielectric plane, whatever you want to, you know, that would be a background wall to a different circuitry, right? Yeah. I'm talking pre-dielectric plane background wall.
Yes.
So it's basically that's how structures can be. It would almost be like background wall, like the thickness of a liquid would be the background wall. Think of it like that. A thickness of the liquid being a background wall. And that way there's a particular amount, and with the fluid dynamics involved as well. So if you think of it in a small container and you vibrate something inside of a sphere, you know, the structure that the water would take inside,
yes,
would be what I'm talking about. You know, as far as now you see, like inside the sphere, you see, you know, a tetranomogram or whatever. Tetranomogram. Yeah. You know what I'm trying to say?
No, I do.
Tetrahedron shaped stuff or whatever. And at the points of the tetrahedron, they see, you know, oh, those are the positive electrons orbiting and then they go into where the intersections are and see that's the protons, that's the electrons.
No, I understand completely.
Every time somewhere,
yeah, with wave mechanics.
Losses is where a point is and it looks like another thing, right? And then it spins, so it looks like they're just orbiting.
Mm-hmm.
Because the whole thing spins as one shape, so it looks like all those things are orbiting when in fact they're stable in their position. It's just they're rotating together.
Right. And I here's my take on all this. Part of the reason why it's not just completely trying to hide the truth. Part of the reason why many people in the field study it from this perspective, is our measuring instruments are restricted to picking up those peaks. Okay?
Yeah.
When we have a higher level or a different ability to measure things, that's where we'll start to see this uncountably infinite continuity to things. We don't see it because our measuring instruments don't see it. It isn't a question of it not being there, it's a question of our ability to measure.
Yeah.
Yeah, we don't have a way to really
That's why I said, wait, how does the Michelson-Morley experiment discuss there being any movement in any ether at all? And why would they expect that light was going to pick it up?
Mm-hmm.
Morally, you know what I mean? Like, and then how does anyone else use that? Well, they found no movement of the earth because they didn't see any movement in the ether.
Mm-hmm.
It's like they're not. You realize in that experiment they didn't know how to measure ether anyway, so
No.
they didn't. It's not like, oh yeah, by the way, we know exactly how to measure ether, and we're going to prove you something right now with the fact that, you know, and then some off next level, you know, this doesn't happen because no ether. It's like, wait, we got to first. That's like talking about Jesus's panty colors again, right? Before
Well,
it's like, well, first we have to establish, did he exist,
Mm-hmm.
right? Or is our measuring equipment even, you know?
Well, in the terms of statistics, what they set up was a false null hypothesis. In other words,
Yeah, thank you.
and what they did was they said, if this shows this, it can only mean this, but that's where they made their mistake. There are many explanations for why, if this measurement comes out this particular way, there are many explanations for how it could have come out. It wasn't definitive of anything. And that's the problem with that experiment. Always has been. It's been, and listen, Graham, that's been documented by many scientists. So they know that this, only the naive think that that was a definitive experiment. We know that.
Because that kind of shit like bugs me.
It does.
Common bullshit.
You want to talk about not being scientific, being scientific naive. Yeah,
mention that experiment. Yeah. Mm-hmm. in some sort of a proofistic confidence.
Yeah.
Oh yeah, we'll
check. That's why I say that, well, most experiments that are done make their mistake right at the initiation of the experiment. Not even so much that they cherry pick results or anything else, but that they set up a false hypothesis. This is the problem with most experiments, and they do it. And in that sense, many experiments are set up purposely to set up a simple hypothesis without realizing that there are other explanations. And they do, you know, certain like funded institutions that want a certain result, so they can put their product on the market, will do this on purpose. Okay.
Oh yeah.
And hoping that you will be
CDC.
And not see through the
flu season.
Yes.
CDC.
Oh my! Don't even go.
It's flu season.
Well, you want to hear something funny about the flu thing? I saw the last episode of that GMOs Revealed series. Dr. Zachary Bush was going through some incredible information, more details about what happens with glyphosate. But one of the things that he mentioned was he was going into how, again, just as we've all begun to learn, how everything in the environment actually is there and isn't there in a symbiotic way to the way our bodies function, everything. And he was explaining how we're just now learning that certain strains of the flu virus, if you want to call it that, or the thing that begins to cause havoc in our bodies that we call the flu, actually is doing it for a very good reason. It creates something in the body. It's an epigenetic response. Something in the body, a state is created where certain proteins need to be created. This particular strains of flu virus create that protein. And so they're allowed to proliferate, okay, in order to turn on certain genes that will create that protein. So here we are, when we get the flu, we fight it, and yet it's our body, the unbelievable mastery, intelligence mastery of our bodies and all the things that are in it working together that are doing something for a reason, okay?
Yeah,
And we don't understand the reason, yes.
efficient.
So what? It gives you a stuffy nose for a while, but there's a reason why you're creating those proteins, because you need them for something.
Well,
Isn't
you
that
need them
incredible?
because you're nutrient deficient. And
Mhm.
that's why
Exactly.
you broke down to create this flu that's creating protein that you're deficient on in the first place. Well, the proteins get devoured and they end up having particular properties to them that are
Well, this is the incredible,
equivalent to minerals and things that we're deficient.
exactly. This is the incredible thing about the worst aspect of glyphosate, is that it so demineralizes everything. And that's why you will get allergies and responses, because your body's trying to recreate things to be able to attach and hold on to these minerals so that they don't get depleted. So in other words, things like glyphosate are creating the backdrop, the environment that then creates these other things. Yeah.
The flu is trying to create a synthetic nutrition for your blood. That's crazy. Balance, right?
Mm-hmm. By the way, I purchased that whole series so that if you want to, we can play certain segments of that back. That one I can even give you. I think that one doesn't work by computer. I can give you the link, and you can play it back live. Certain of the because there was information in that series that aren't contained in any videos on YouTube, so it might be useful. I mean, what it basically showed was that the combination of these GMOs and glyphosate and the two other heavily used pesticides, 2,4-T and I forget the other name, that they literally are reducing our bodies down to not being able to even create anywhere near the complexity of compounds that they once were able to create. I mean, it shows beyond a shadow of a doubt that it's going to turn all life into a jellified form. In other words, it's not going to have the same complexity of function that it once had. Yeah.
Yeah, it'll make us more susceptible to widespread disease.
Oh yeah, it will basically
epidemic type effects could be more observed because of this widespread, basically nutritional deficient population.
Yeah.
You know?
Well, and like I say,
widespread
protein productions that it's turning off is incredible. Like I said, it's literally reducing the complexity of life back down to where only the simplest single cell forms will be able to exist. And even they might have a difficult time. And that series did a great job in showing that. Yeah, I was really impressed with it.
Well, life will go on.
But what
might
form
not be
of
our
life?
life? Yeah, that's what I'm saying. Might not be ours.
May not like what happens. It has to be stopped. This whole chemical approach has to be stopped. It really is. It will kill everyone, including the people who are doing it.
You know what? You're right. And doom gloom, and I know. And there's sometimes you just got to get outside and forget about it for a day, or try to take your mind off of it. Go jet skiing. Go, get on the boat. Just get in the boat. Just get out in the water. Enjoy that water for a minute.
Well, the thing is
the
effects are so encompassing that we've got better arguments than ever to be able to put a stop to this. It's just that the word has to be gotten out. People, if people everywhere knew even what we know on this would be over. It would not be going on anymore.
I know. Well, they're not going to get it from me, obviously, because I've been trying for years, and I'm not organized enough. I'm not ass kissy enough and PC enough and all that shit enough.
I'm getting less so myself every day. I don't have much.
I don't like it when a full-grown man comes on and is like, "Hi, my name is Brenda. Everyone must call me a she." And then when he's talking to me and I say he or dude or whatever, and someone's like, "Oh, you're not being polite." It's like, no, that motherfucker's not being polite. That motherfucker should not be requesting that people be calling him a girl, because it's fucking confusing and bothersome and annoying that people have to do that shit. I can't fucking remember who the fuck is a boy and who's a girl, and we all sound like boys. The fuck out of here. I'm responding to the boy voice. You know, that kind of shit right there bugs me.
In more general terms, there's no more time for this silliness and for things that don't matter.
Right.
I mean, nobody's taking anybody's rights away, but let's just, you know what? The issues that matter are these things that are killing the entire living matrix. Can we focus our attention on those things?
Yeah. Who's going to care how you feel about what people are calling you when you're already dead? Nobody.
Yeah, exactly. There's just no more time.
Why are you fucked up in the head in the first place? Let's investigate that.
Mm-hmm.
And what makes you think, if you're a man in a woman's, or a woman in a man's body, that you're not fucked up in the head? Someone transplanted the brain over there. That is a brain problem, right? You have a, you know, it's like, come on, man. You just said it yourself. You're in the wrong body, so you're definitely having a brain problem. Huh? Don't see what you're saying. The implications of what you say mean something. You just have to inspect them. You know, inspect what you've said.
I just checked the chat.
We already have handicapped bathrooms. We don't need new bathrooms, and taxpayers, and we don't need taxpayers paying for extra abortions, 5 and 6 average abortions for these Planned Parenthood ladies and shit. What the fuck is going on?
Well, you know what's going on with
We're
that.
having way too many abortions. Yeah, they just culture the same baby cells, right? What are they using all the other cells for? Make more GC-MAF?
It's incredible. It's like mass insanity. You know what I mean? It really is. Yeah. You just want to say, get me on a ticket to the train to the next planet. I'm done. I'm done.
Yeah, or let me make my own flat Earth here on Earth. Put a dome around my shit. Get the fuck. I don't want to breathe your air.
I know, that's the way I feel sometimes.
Yeah.
Like just that old log cabin up in the mountains and leave me the hell alone. Yeah, I know, it's crazy.
Right? Shoot, I wish I had some good equipment and I could investigate that kind of idea, because I would like to get in between like 2 iron mountains, you know, and then have this strange seclusion zone, a magnetic field that keeps clouds and chemtrails and particulates from the sky out of my sky.
You know what you just described? You described my Shangri-La, okay, what I named myself after, Lost Horizon. That is the premise of Lost Horizon, is to create a secluded area where you can preserve the best of what man has learned and live in a different style. And then when the madness outside is over and the people that are left want to live a reasonable life again, everything that was good was preserved. That's the whole premise of Shangri-La. Yeah. It's funny because that's where I got my name from.
Does anybody here know 69?
I was just going to ask if you wanted to let him. I don't know him.
I don't know either. I don't let people on I don't know usually. Too many weirdos out here doing dumb stuff. Not saying he is one, but I'm not.
It's difficult.
They like
hi to Matt too. He's out there. Oh man.
Does look familiar though, right? He's like, guys, you know me.
Yeah, I've seen the name, but I just don't remember. He's just like he came in a few weeks ago. I don't know.
All right, we're gonna give it a shot. We'll give him a shot.
Okay.
What's your G plus? 69. I don't want to talk about flat Earth crap. We're not going to talk about flat earth, are we? It's a waste of time.
Oh, I was just looking at his YouTube. He's mostly into the computer tech stuff.
Oh, okay. No, I know you now.
Yeah, he doesn't seem to be flat earth at all.
I know him from here, from this, I think.
Yeah,
There you go,
it's
bud.
funny, when we first started, we never wanted to be that fussy about when we let people in, but everyone learns that here. It's like after you've been here a few years, it's just, you know.
I got too many haters. He's been in before, but
Hello.
Hey, what's up? Let me show you in the broadcast. There we go.
There you go.
This is how I remember you. YVS.
Yeah,
Yeah, this is me. I can't believe you forgot who I was. Come on.
No, I understood the avatar. It looked familiar, but it just doesn't seem the same.
I get it. You deal with a lot of
YouTube.
people. Yeah.
Well, no,
yeah,
you weren't the same
you
person
would
on the
be
YouTube.
surprised. Yeah, some of the characters.
So how's it going, Matt? How you doing, man?
Oh, I'm good. I just not been watching for a while. I just joined in at the end and kind of caught what you were discussing.
Oh, we were just kind of
Yeah. What? Okay.
Go ahead. There's a lag, I guess.
Oh, yeah. No, I mean, I don't have anything to say. Yeah, I was just going to listen in and then maybe chime in with some points when I felt it was necessary. So.
Well, let me ask you this. You've probably been studying a lot of the newer developments in various fields of science. What sparks your interest the most in what you're seeing? Or put another way, in terms of establishment science, where do you think what's presented has gone off the wrong track? Okay, and what areas might need better explanation, just from your own gut feel?
Scientifically. You mean?
No, politically, establishment-wise.
Oh, what's going wrong? Okay.
Right. Because I'm sure I think we had a discussion about it before, where we were talking about how there was problems with the peer review. That was you, right? Problems with the peer review, publishing, so people rely on their appeal to authority about established industry funded studies and things like that.
Yeah. It's a hard question. What's the most pressing issue?
It's a segue question. She just wants to lead you into a conversation about it.
It's a hard one. Right this moment. I don't know. I mean, I've been hearing a lot about this. I guess is it even really worth mentioning? The Antifa and the other. I don't know what the other side is. The white supremacists. Quotation marks. I don't know what's really going on there. Who's involved?
It's all a show. Yeah, it's all staged.
Yeah.
When the two factions come in on the same bus and they were completely amicable with each other on the bus, and then they get out and then they're sort of like protesting each other and trying to kill each other. Yeah, I think we know what's going on there. They want people divided, so they set these things up and try to get everybody else riled up and hating each other, and so they don't work together and figure things out for themselves.
Yeah, I mean, shit, left, right, then they put, you pick one or the other. They're both controlled, left, right. It's just so simple. They keep doing it over and over again. divide, conquer, you know, chaos, order.
Eventually isolate
Boring
everybody.
now. It gets boring. Every time you turn around, it's like, oh man, you know, did you see that on the news? How they're rioting and fighting about this race thing, and they're tearing down these statues. I'm like, you know, that's all government.
Yep.
All government doing that. They want you freaking out right now, obviously, because look at you. You know?
Graham, someone in the chat thinks you're Charles Manson. It's that beard.
Right, and yeah, Charles Manson is actually an ugly motherfucker.
Oh,
But yeah,
yeah.
props on the beard, dude. That's the first thing I noticed when I came in. I was like, oh shit, he's got in with the beard.
Charles Manson can't grow a beard like this.
Oh, he looks like something else these days. Yeah, he's.
I don't know who that is.
It's real. There's a real thing, you know. It's a real bit between guys. Beard envy. That's what guys fight over. Divide and conquer. Who's got the best beard?
Yeah, man, that's it. It was better, and then now there's the gray, so now it's the best. Just kidding. But seriously, that's all that divide and conquer shit. For real.
Well, yeah, I mean, anytime I know Antifa are involved, and I don't know that much about Antifa. I get the general gist of it, but I don't know. To me, it seems something kind of sketchy every time I see this Antifa thing. Mainly because it's easy to, especially when you're talking about anarchist groups, it's easy to use agent provocateurs and to stir up a lot of trouble and it be kind of swept under the carpet because people don't really pay attention to anarchists as much. And, you know, they have like a preconceived notion of what they're about. So, you know, as soon as they see trouble and someone goes, it's a group of anarchists, they go, oh, well, that makes sense. Of course, it's anarchists. They cause trouble.
Anarchists aren't out in the street yelling and begging for rights. They're at home, they're at home using their right. They're what they want to do and what they fucking want to do, rights or not. Right? They're not asking for your permission to do. And that's not a real anarchist. If he's out in the street yelling about anarchy and shit, not even a real anarchist. That's not. That's the opposite of. That's a servant begging for rights out in the street. Please, I want my rights. You know, nigga, I take them. I just be here doing my shit. I don't need to be begging for stuff.
Yeah. It's true.
I think it's stupid. It's another way to rope a group into looking like a bunch of jackasses. Because just like you said, now you can throw on masks. Let's make it fun to hide our identities too, right? Then any jackass with a mask can just do any old fucking thing under the name and the guise of whatever stupid ass little group allows that shit, and they'll always be infiltrated and destroyed. You know, you might have some good people who want to do good things and they're going to follow the dumb leader because there's always a leader for some reason in these things of independence. You know, I was their leader in my independent group, the official Anon channel.
Yeah.
Shit's funny, y'all.
So, yeah, I mean, what else? I mean, there wasn't around. There was some sort of statue, and I mean, I don't know much. I learned a little bit of the history of this dude.
All
Is it General Lee?
Anyway, this shit wasn't even real history. We weren't really warring for those reasons anyway. It was never about slavery and racism and all that shit with the wars and all of that. It was about not having our sovereignty in the South anymore. The North had slaves. It was legal. It's not like it was illegal in the North and then not in the South. No, a lot of the Northern generals had slaves and shit, you know, in the middle of the war. I mean, did you think Abe Lincoln, not you, but I mean, most people out there think Abe Lincoln was an abolitionist until you read some of his quotes and you realize this motherfucker was an opportunist.
Mm-hmm.
That's it. He's just telling you, the public, the lie that you need to hear in this sector. You, the public, the lie that you need to hear in this sector. That's it.
Well, ironically,
win this war without freeing a single slave. Tomorrow I do so.
Well, I don't know if this is true, but it has been written, ironically enough, that Robert E. Lee actually didn't have slaves. And they tore his statue down. Yeah.
Right. Yeah. And plus, he also understood that we were being usurped through legal paperwork.
Yes.
And the Constitution to the Confederation and the legal debts and the bindings to the debts from the states, and then the states being set up in districts, and then the districts, people being assigned to districts and therefore binded to the debts that continue to accrue because Congress can keep borrowing from the same bank, and we can never be free from this situation ever.
Right.
And they set it up like that. And the South was trying to say, no, we want to print our own money.
Exactly.
We don't want to do that system. And that's what the war was about, guys. It wasn't about the fucking race and the slaves.
Well, and that's what they meant by states' rights. The ability of the state to determine its own currency, or, how it's going to, what kind of method of currency in exchange it's going to use. And that's what they referred to as states' rights. And that the people that fought in the South, that was their motive for fighting, was the ability for their individual state to determine its own destiny.
That's right. See, and that's why this states, that's those districts and everything was such an invasive maneuver, and create the federal districts, 16 of them, was such an invasive, conniving maneuver. And what could they do worse than that except for create the United States Bank and then have 25,000 shares, with only 18,000 of which were already owned by those in foreigners, England and France and whatnot. The King George, basically.
Mm-hmm. Well, from my reading of the history during the 1800s, especially if you go to individual people's diaries, where you get a better read on what people were really thinking back in the day, they much better understood the phony money problem, okay? And the centralization and private ownership of money. They understood those concepts.
The word fiat currency meant something then.
Yes. Right.
Now it just people glaze over fiat.
Well, I guess it was a lot simpler back then as well. I mean, it was kind of like, you come here with your piece of paper and we give you the thing that we've promised you in return for that piece of paper. And then, all the other the things start creeping in. You've got, like overseas accounts, and you've got credit cards and numbers and all these different banking systems where your money's, sent all around the world. And then, you go to the bank and your money's been taken somehow, and it's involved in stocks and insurance. And before that, it was all simple. It was just like,
it was supposed to be transferable in gold.
Right. Another reason why the people of that time understood this problem better was they were in more direct contact with the thoughts of their more immediate ancestors, who first came over here in no small part to get out from under the tyranny of Europe, the European bankers. They understood that. And
that's right.
Children, and that's why they could recognize this bullshit when it was brought to this country. Okay.
And it was here in a heartbeat.
And they fought it. During the 1800s was the biggest time of fighting those centralized banks in our history. They understood it. They fought it. Now most people don't even understand it.
People don't realize back then, man, when a band of outlaws came and murdered particular towns, it was government.
Yes, it's always been.
Those are government. Those are the Billy the Kids, and these are government. Those fuckers, man, they were actually hitmen for the government. The ones that got famous and continued to keep on continuing somehow. Well,
the thing is when you understand that.
I just made that up. I have no idea.
Yeah, that the so-called global elite through governments operate like a mafia. If you understand that,
that's what mafia was in the first place. Right? They were government. They were never just some freelancing Italians. It was always CIA. Yeah,
that was another way to shift
Church.
blame and make a scapegoat. Yeah, exactly.
And I mean, even if they're not, they're still in cahoots with some of the people that were. It would. I can't with a force as powerful as government. I couldn't see it being possible for you to own a mafia without being in cahoots with the government in some shape or form. I mean, just take an extreme example, right? Like imagine the Godfather, right? Just a silly example, like so a guy like that owns as much property and kills as many people and has that much influence and money. Like, you don't think the governments are onto him?
Future fascism is what it is, under the guise of a single man. Right? That's what it is. They set it up like that, where it's like one single man is doing all of these amazing things, right? One single man all by his lonesome doing these things, right? And it's literally just, it's like a face company for government rollout shit and new setups for new fascist control. It's like they know that. Let's just take, for instance, the painting industry, just painting houses, make it simple. You know, it's like, imagine government wanting to be in the painting houses business, right? Well, what they would do is they would paint houses for cheaper than anybody else can paint houses for, just to put you out of business. And so they would control the market and create a vacuum there that they can allow only their companies to come fill the vacuum, because one company just doesn't want to do it all. You can sell that off to all of these other companies. And it looks like now you've sold off your company, one who was once him, you know, the big man or whatever, right? The one man who did the whole, controlled everything, and all broken up now into all these little companies. So you can't trace it back to the one culprit situation anymore. Now it looks like it's branched out in all these different places, but it's still one organization running through all of, you know what I mean? And you know, then you realize, oh, look, all those corporations end up at bottlenecking into this one banking zone.
Yeah.
Oh, look, the board of that banks also have board members or one or more on each one of those companies. Huh. It's all linked.
Oh, yeah. No.
300.
I've always said, look at the board of directors for companies and look at the connections, and then you'll kind of see the bigger picture real quickly right there by doing nothing else.
Yeah, you've already known. It's like when people say, oh, Bayer and Monsanto are going to merge. Well, they've always been merged.
Of course. Same
at
people.
The bottleneck where I've been talking about, like I saw their connection 2 decades ago when I first started.
Who did he say is going to merge? Who and Monsanto?
They always merged in that bank. Well, yeah, but they merge on such a level to one of their board members and one of their board members are both sitting on the board of this bank together.
Who is it?
He's talking about Bayer and Monsanto.
Bayer and Monsanto. Yeah.
Bayer and Monsanto.
Yeah, big companies. All sorts of shit like that going on though.
I thought you said
Monsanto.
Bayer.
Because they're just recently merged. Yeah.
Mm. Talking about the CEOs and one of the things that I know, you know the company Bayer or Bayer?
Yeah, Bayer. Like Bayer aspirin.
Yeah, Bayer.
Chemical company.
Yeah, Bayer aspirin. That's the one. Yeah, they originally started out as IG Farben. I think gave the Nazis the gas that they supposedly used.
Yeah.
They made all the dodgy chemicals.
They use those companies to sell propaganda stories about historical events too.
True.
Like, let's say you come to find out HIV does not cause AIDS, so you cannot give AIDS to people through blood transference. AIDS isn't, you don't get AIDS from somebody else. AIDS is an acquired immune deficiency syndrome. Acquired immune deficiency syndrome. Mm-hmm. Acquired immune. You know what I'm saying? Not like, you know, somebody, you don't acquire it like that. You acquire it by, you know, chronic bombardment to your immune system. You know what I'm saying? Like that's just ridiculous. So as far as that, when you look into that, you find out that what I'm saying is true, and that HIV is not sexually transmissible, and that HIV does not cause acquired immune deficiency syndrome. It's not the cause of that. You start looking into that kind of stuff, then you realize when they sold you stories like Bayer sold infused blood, HIV tainted blood to, and you know, like they killed all these people and they didn't.
Well, the story on this, I was going to say the main CEO, he was in apparently, supposedly this is the history on it. The dude, what are they called now? The Nuremberg trials. You know, where they're supposed to have tried all well, apparently he got sent down. He went to prison. This guy, he was like one of the top guys under Hitler, one of his consultants for this company, and as soon as he came out, they put him straight back at the CEO of Bayer again.
Yeah, it reinstills the idea that the Jews were in a Holocaust. It's propaganda. Mm-hmm. Where's the 6 million Jews this time? Right? Because there were 6 million Jews in 1915, then, 1918, and then again in 1941, right? Or whatever. So which time was it? The real 6 million Jews? This time, that time, the next time? The persecuted ones, the story was sold, homie. All right? Those were shower heads and shit and delousing fucking rooms. Why do you delouse somebody if you're going to fucking gas chamber them? Why do you feed them and have picnic tables and shit if you're going to gas chamber them?
To play devil's advocate, I don't know anything about this situation, to be honest, but the thing that I would think people would say is that they used to wigs. They used to sell all the hair, so they would delouse them to sell the hair on. And not just wigs, or other uses. I don't have any idea. That's just what I remember hearing years ago. In school, I think. I think that was something I learned in school.
It's just silly. Super silly. Using pictures, they were using pictures to say, look, these are the Jews, right? And they were actually not Jews, and they were sick people from, different, had this certain disease that he made his ribs fucking bend out and shit. And it's like, that kind of propaganda was so easily accepted in the past. It's only right now that some people are waking up to CNN not really being there, pretending the bombs are happening. Oh, God. This kind of shit. People are just waking up to fake shit.
Mm-hmm. Oh,
this has been going on since before the writings of the Bible. Mm-hmm. Think this way. Do like this. Easily governed. People are just.
What is that hysteria about fake news? It's like, you guys never heard of propaganda before? Like, do you think this is a new thing?
And it's to make people wash over about propaganda altogether when they hear it said, like, no, your news is fake news. No, your news is fake news. And then it's like, it brought it to a childish level of fake news, instead of where it was, this is propaganda. Mm-hmm. It's more serious to understand it as propaganda, presenting a particular agenda than to just vaguely, arbitrarily yell out fake news and and then it sounds like, and then one person saying that this side of the news is real and their news is real, but that news is fake, and then it's like the fake calling the fake, that's the game being played. And so the fake calls the fake, and then you think that the fake is fucking, has some validity to it because he's pointing at an obvious fake. And now you must have validity because you pointed at an obvious fake, even though you're also a fake designed to be the fallback from the fake that you're pointing at. Now Alex Jones is yelling fake news, but he's also fake news. You get what I'm saying? Mm-hmm. It's a way to trap people into accepting a validity in alternatives that are not really alternatives at all. Mm-hmm. He also told you to vote for Trump, right? He said vote. He told you that the system works again somehow all of a sudden. And Trump is not an insider, he said. And it's okay to build a prison wall around yourself.
I mean, I think it's also confusion as well, not only just to point people into the wrong direction. I mean, I guess you're right. Yeah, people were.
Well, as long as they're going in all different directions, everything's fine, right? If pointing that direction, what does it matter? As long as you're not going forward. Look, no one's going straight up. Yeah, everyone's divided leftish, rightish, extreme right, extreme left. Everything's never going up.
I watched a documentary on it was on politics, but it involved Vladimir Putin, and it just reminds me of what you're saying about this confusion and the fake news. But this is something he did a while ago, and what he would do, Putin apparently, so would be he would fund both sides.
Yeah.
He would fund both sides, the people that were against him, the people that were for him, and all the in-betweens. And then after doing that, what he would do is tell them that he had funded them. So then the groups themselves didn't even know who to trust. They realized, even the groups that were against him realized they were funded by Putin, so they couldn't even trust themselves anymore. So he funded them, like kind of covertly, and then in the end told them, just to create so much confusion, like.
Yeah, and to create a good mask and a cover for all the movement of money and distribution of, materials and things he was moving around at the time too. So that was a great cover for all of that.
I was going to say.
Yeah. Oh yeah. We moved those trucks for a particular reason, because we know people are watching, and we don't want the public to know that we're making a big mass movement of, materials or grain or anything right in front of them, or that we're bringing in a bunch of chemicals and shit like that, or there's like all kinds of shit going on, man. It's one thing is usually just it's a watch the hand trick, because there's another thing that you never even got to hear about going on. It didn't come up on social media. What's going on though? That's what's happening out here. So,
it's all shell game.
Yeah, it's all fake news from your alternative media too. I mean, for the most part, if they're not talking about the grand solar minimum, and if they're naming themselves grand solar minimum, I'm leery, because it's hard watching the Weather Channel. Just kidding. You know what I'm talking about, Debbie?
With reference to the grand solar minimum?
That channel that I thought was going to be more educated on the electric universe stuff.
Oh, yes.
Are they not as, or what did you get out of them?
Are you talking about ED 2.0? Is that the one or a different one?
No. Actually, the grand solar minimum channel.
Oh, yeah. Well, a certain friend of ours did a little research there, and I was a little disappointed to find out that there were no definitive people behind all that. There was a lot of masking of identity going on. So obviously at this point, I have to allow for the possibility that they were placed there. Yeah.
Isn't that kind of strange? They don't seem to be touching on the exact methodologies or whatever. They're just kind of soaking up the meme, you know what I mean? The theme of it all. And
and
I don't know. It seems like, I don't know, man. I just get bugged by it. I see a lot of nothing happening in places like that.
Yeah.
Where something could be happening.
Well, another dead giveaway is when somebody comes in and asks a real reasonable question in a real reasonable way, and they're not allowed to ask that question. You will never see that on other channels that are really trying to disseminate what they think is truth from their experiences, from their experiments, from what they've learned. they're always open to questions, as long as they're legitimate questions, questioning the actual information. And that was a dead giveaway for me. Was there? I've never seen how they just. It's almost like all they really want in their chat is just very. Don't talk even about the issue of the grand solar minimum so much. They didn't really want any heavy discussion in there. And that was a little bit of a dead giveaway.
Right,
yeah.
like there wasn't a lot. It was almost like pointing, you know, oh, squirrel, every time you want to bring up the subject, you know, oh, squirrel, oh, there's something I want to say about some other random, you know, just avoiding the detailed mechanisms. That's what I was trying to get at one day.
Mm-hmm.
Glad you noticed that too. You know, I'm always.
No, I noticed it right from the beginning, but they were the first channel that.
I'm so negative, right? Because like, you know, and I see it. I see what it looks like, right? When I get somewhere and I'm like, problems with this, blah, 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 you know. But, you know, if it wasn't for people like this, things wouldn't get fixed. Or, you know what I mean? I'm just saying, like, if I'm just going to sit there and accept a bunch of nonsensical talk about something that when someone's claiming to be on a particular subject or about it, or they're getting views for, you know, that subject in particular, and they're not really representing that subject properly or at all in some cases, then we're supposed to say something.
Yeah.
It's fuck. What the fuck?
Or else what are we doing here? Exactly.
Otherwise, you're wasting. You're not supposed to sit there and just try to make friends anyway. That's what they're catching people doing.
Well, that is one of the Delphi tactics, is a method of always distracting away from talking about what it is that you've learned that makes you feel a different model of something is a better representation. If they don't ever seem to want to allow you to talk about that.
No.
And another aspect, another critical red flag, is when they can be super critical to you on the most banal level, okay, where they're not really getting to the hardcore things you want to present, but it's a more of a diversion tactic of super criticality.
Very vascular.
But wait a minute. But then they won't be critical about what the supposed authorities model is. It's like they won't allow any criticality discussion on that, on the established models. But they're so super critical of you, they won't even allow you to explain your position.
That's right. Because
I mean, that's what they do. Yeah.
It's like, oh, what does do mean? Do you said do. You know what I mean? Like what is,
exactly. They're arguing
what is what this? What is this? What is?
Well, and the irony is when they do that, you found as many, if not more, things in their speech you could have argued, but you overlooked it. You were trying to just get the gist of what they were saying.
Yeah.
But then they turn around and the very first one time that you maybe use an adjective as an adverb or something, they're attacking you. It's like, what?
Right. There's no give in the understanding.
Clearly, it's just a way to end up spending 5 hours talking about nothing and establishing nothing, wasting everybody's time, and that is a Delphi tactic.
Yeah, it's annoying too.
Yeah, because I don't have time to waste. Yeah.
Yeah, it gets obvious. And the better you are at noticing it, the more of an asshole you look like to the unsuspecting crowd.
Well, because they're just irritated that you caught them. That's all.
Well, no. I mean, to the crowd.
Why are you asking questions, dude? It's not cool. You can't question me.
Right. It starts looking weird. Like you don't like him because he's, contradicting you.
Yeah.
Right. Or doesn't agree with you is what the most common one is. Oh, he just doesn't agree with you. So you're just fucking lashing out at him because he doesn't. Mm-hmm. But when he voiced his opinion that he didn't agree, he said, that's fucking ridiculous. Right. So that part wasn't rude. He didn't, for some reason, it wasn't seen that this person is insulting me first. Right. When he's saying something that I'm saying is fucking ridiculous. Obviously, if I put this much thought into something and it's fucking ridiculous, then you're making a statement and implying something about me. Now, no matter how subtle that may be, right, of an insult, it's still a fucking insult.
Well, and basically what they're doing there is, again, they don't want to argue the information you're putting out there. So they try to completely nullify you by simply saying, well, he's just an asshole.
Yeah.
It's like, well, what about what I just said? Do you have anything to say about that?
Right.
Yeah, we discussed that.
Yeah,
No,
that's kind of like arguing with a flat earther. Or yeah.
Here's the thing, though. People.
Why did I bring that up?
Yeah, people that do this, they're becoming, at least to many, more obvious every day. I see it in text chats where people are saying, well, they'll start to say, like, I don't necessarily agree with what this person is saying, but why don't you talk to them about that? It's like they're noticing that it's turned into an ad hominem every time, just to nullify without looking at what the person is saying. It's a way of completely trying to push you out of the picture without even, being able, having to argue against your position on something.
Is that, how do you think we got through high school? I mean, there's people, I don't agree with most girls, but I like their presence.
Okay.
In high school, it's like, whatever you're talking about is fucking, yeah, it's great. I mean, I'm not into the colors you're talking about or whatever the shit is.
That's kind of like hominem in reverse. Yeah.
Let's go get an ice cream cone when you tell me all about it, babe.
I'm going to tell you something that can create for a very frustrating moment for the female. It's like, I want to talk about this thing, and it's like, yeah, whatever.
In high school, she's not talking about that thing. She's talking about this other thing that you don't care about because she's in high school, and it's about the color of Bridget's new shirt that she had.
Oh, I see. Yeah.
Plastic sequins on, and then you got to hear that shit. But so as long as she smells good and is nice, and then you can eventually interrupt to say something else later, that's fine because you love girls. You know what I mean? So you love people too. That's what I'm trying to say. We learned how to not have to agree with someone to enjoy their company a long time ago.
Oh yeah, that is a sign of
relearned. You learn not to be like, you're not to be tolerant when you get online with people because there's no consequence to your intolerant behavior, right? Like in public, there's consequence to your intolerant rudeness. Trust me. Doesn't matter who the fuck's watching. You get fucking thumped. But in the computer world, none of that is possible.
I think isn't that, it's kind of what you're saying. I don't know if you would call it a macro and a micro level, but what just kind of cropped up in my mind when you were talking about that is personal responsibility and the fact that it's kind of dispersed because people can't see the, I don't know, fruits of their actions as easily. Like you said, you're not face to face with someone, you're not in front of someone, and it's the same on the macro level when it comes to politics and government and the economy. It's like there's no one to blame. It's very ethereal.
Here's another reason why it works that way. Here on a platform like YouTube or G+, whatever, you know that if you screw up, if you treat people badly, you can always just create some other account under another name and be a different person and can still do whatever you want to do on here. But in real life, you are always, your actions are always associated with you, your name, your person. So if you mess up with people, it's established, it's on the record, it's you, okay? Whereas here, you can split yourself up into 100 different personalities. You know what I'm saying? I think that's part of the reason for the dynamic that we see here, where the unbelievable level of rudeness that can sometimes occur.
Yeah. And like Delete's in here saying in the chat too, the confirmation bias, the polarization works in a lot of areas, like in the medical industry and stuff like that too. This is what he's saying. It's applied everywhere, that idea of controlled opposition, left, right, industry versus fake independent. Remember, because we caught that FOIA information, Freedom of Information documents of the emails between the so-called independent journalists on the editor staff, on the journal staff, editor.
Yes.
Yeah, so that's that same dichotomy. It's a fake dichotomy, independent versus industry, both spewing industry results, stuff like that too. That were
Well, and you can't underestimate the pressure on professionals when they know if they go against the grain, what the funded entities that fund all this want done, their career in that capacity is over. And that I was having a discussion with someone the other day why you see most of the independent scientists that are able to do a certain level of independent research are older people, because they're no longer so dependent on that system anymore. Okay. And why, when you first start out, like a first BS degree microbiology student, he is more dependent on that system. And that's why you see so many times 20, 21, 22-year-olds are sitting there defending the system like nobody's business. Okay.
You got that right.
Yeah.
I'm talking shit about
You
you.
know some of the people I'm talking about. And of course, it can't go without being said that the longer you're in a business, that's the more it becomes evident that some stances are promoted and other positions are definitely not promoted. They won't even let you look at it. They don't want you to propose a study in it. Well, here's an interesting
example.
point.
Oh, go ahead. Sorry.
I was going to say, all these agricultural organizations, okay, that you would think would be more interested in independent studies of glyphosate and GMOs than anybody else, won't touch it. They won't touch it. Dr. Seneff was talking about this just the other night on one of the GMO series. And she said it's incredible. There is no research on glyphosate coming out of all these agricultural organizations that do all kinds of research.
Guess
but they
what?
won't touch it. Yeah.
Same banks, same ownership, same government. They all, they're all workers for the people. Think I own a farm. I own a farm. Well, obviously no, because you don't own anything. If you break it all down, you actually don't. And on the bigger levels, like huge, government subsidized type fucking levels, right?
Mm-hmm.
You have the limitations, and you have inspectors, and you have to be within the parameters of their guidelines. Otherwise, you don't get the big benefit of being their employee, which makes you think you're your owner. That's it.
Well, Dr. Seneff
like
was
a franchise.
talking about, Dr. Seneff was talking about how the only reason why she got funded for her work was because she was funded by an Asian company that is interested in promoting the use of more sophisticated computer information, IT techniques for collecting and analyzing data. So they didn't really care what she studied. She was showing what you can do with IT, with statistical data, right? And so she got funded that way. And she said that MIT, in fact, she doesn't think they get any money from Monsanto type stuff.
Well, the fact that she found something that they couldn't even hide, they hid basically. Remember how I used to say, well, look, I read the same thing that everyone else read, but I got this out of it.
Yes.
And then I would go right to the very important meat of the points. Well, that's how their algorithm actually, works. It goes in like one of those book reader things and bookmarks all the pages where those certain words came up or something. Like, I mean, that's basically pretty simple, easy shit. When you do that, you realize that something is being said here that you didn't put together through the confusing verbiage in the first place, and things are being, hidden through confusing verbiage.
Well, that's the beauty of Dr. Seneff's work, is that she is using new ways of analyzing data on the computer that allow you to take what seems like disparate data. So you can get data that's already been developed by all these different research studies, but bring it in such a way where you can connect the dots. Okay. And that's why she's able to see connections between all these different kinds of diseases and glyphosate that nobody else is picking up, because each of those studies was done separately.
Type level. Yeah.
It's incredible
awesome
work. Yeah.
I saw
Well, isn't that a lot? Isn't that a lot of the problem with science these days? That it's very specialized, and the disciplines don't seem to interact with each other for a more holistic view of things.
Well, and this is so critical when it comes to biological reaction, because if the biological matrix of this planet really is in such a way where we don't really exist biologically speaking as independent beings, but we are, I mean, even epigenetically, everything about us is affected by every other living organism within our proximity. And we've evolved with that in mind, and it's all complementary. You've got to be able to break down soil sciences with, you know, microbiology, with systems within the body sciences. You got to be able to pull
all the way down to the electromagnetic field dynamics.
Yes, yes, even the physics of the very small. You got to pull all that together, or you're not going to understand the. Literally, they talked about, if you really look at all the reactions out there that affect us and that we are affected by and that we use, you're talking 10 to the 31, 10 to the 31 more stars than the observable universe of different types of complex reactions. How are you going to understand this unless you can see it as a bigger picture? You can't. And that's why every day they come out with more news about, hey, we didn't think the immune system could work in this way, but look at what we just found. Another little piece, another little piece. We didn't know this, which is all the more reason why you start messing around with GMOs or things as toxic as glyphosate and so many other chemicals that they're putting out there. You have no idea how many switches you're turning off when you introduce these substances.
The thing is, this some of this information has been known for a long time, thousands of years, if not more. Especially about things like the gut-brain barrier. Like ancient cultures were pretty savvy to how important nutrition was in feeding yourself with quality food and exercise and keeping the soil healthy and, you know, sunlight and all sorts of things like that. So it's not, I wouldn't say it's new information. It seems like people are just rediscovering it now, and it's still not that mainstream.
And in a certain level of specificity that, at least historically, was never documented about it. They may have known the specificity 10,000 years ago, for all we know, but they didn't document it. We don't have any documents that show it. Now they're seeing, you know,
they don't specify. It's a lot. It's simple science. It's simple language. It's not complex nutritional language and, you know, chemical formulas and things. It's like you put green stuff in your mouth that has leaves on it, called vegetables, and you get well.
Yes, they understood it at a
like
more
it's
functional level. Yes.
So I don't know. Have you guys, just because you mentioned the immune system, are you guys privy to Wim Hof, a guy called Wim Hof, Dutchman?
It sounds familiar. What specific studies?
He's called the Iceman. They call him the Iceman. Do you know about this dude?
I've heard about the Iceman, yeah.
Well, what he was able to do, what they found out recently, I mean, he's known that he's been able to do it for decades, and he was called crazy, and no one took him seriously. But what he basically does is, I'll give a quick rundown. I don't want to rant too much about this, but Wim Hof, you know, he was a dude that was into, you know, like spiritual practices, meditation, things like that, certain philosophies, Buddhism, all that sort of stuff. He went on a search to find, you know, some meaning for himself, and he eventually came across something that kind of calmed him and made him feel at peace, you could say, and that was submerging himself in ice cold water. So he used to jump into like frozen lakes and things, and he would meditate while he was in this ice cold water, and eventually that developed some kind of it made his body stronger, and it allowed him to be a lot more resistant to certain ailments. So anyway, the point is,
they call it stressing the system. When you stress the system, you allow certain new chemical.
Well, that's what he was Yeah, you call it cold shock proteins. He activated cold shock proteins apparently.
Sort of
yeah,
like
you're
the
right.
flu, like
Yep.
the flu would give you these some particular proteins that would add a nutrient.
It's
But if he
exactly-
wasn't so damn deficient in the nutrients, they wouldn't find that they need to be, you know what I mean?
Yeah.
Replaced
Well,
so hard in the first place.
The point is that this dude, they did an experiment on him, and they injected him with some. They injected this dude with this thing called an endotoxin, and what he did is he basically meditated, and he's able to activate his immune system through meditation by thinking about it, by concentrating his awareness on his immune system. And this isn't like some kind of woo woo, fake YouTube video where some guy can heal himself. Like, this was, they did proper studies on him. I mean, maybe, everything's questionable, but it seemed pretty legit. And the point is, science, do they call it autoimmune response, isn't it? The autoimmune response. Or is it autonomic?
Well, yeah, again, those terms they engulf so many different things too. So,
one of the words means essentially that the immune system is controlled automatically. That's what I'm getting at, and he proved that
antibody response.
My point is, it's automatic. Whatever it is, the response that your body has to some kind of invader, and he is able to, control. It's not automatic for him. He's got control of his immune system. So that's like I don't know. I feel like that's a pretty huge discovery. But I mean, that's not even many people know about that. But he can teach other. It's not just him. He's not a special case. He can teach other people to do it.
Yeah.
And this guy's kind of on a mission to like tell people like this. You can heal yourself. Like, I'm able to do it. I'm able to teach people to control and activate their immune system with the mind. But obviously, that's not something that Big Pharma would want to get out at all.
Yeah.
No, there is a lot to that. Of course, understanding now that you're talking about the power to do that obviously exists because of the electrical nature. You're changing the electrical connections that are going on, which changes what gets turned on and off, which changes your body chemistry. All those things come into play. But remember, if you want to get a specific positive result, in a way, though, you have to know all that complexity. Not to say that you have to know it in the way that science demands that you know it by experimentation, but you have to. I guess what I'm saying is like it's kind of like, okay, the idea that if you want to set up a specific kind of electromagnetic field around your body in order to induce a very specific positive result, it is complex, okay, because that same field, slightly altered, could produce a negative effect, okay? So I do think that the key to that is in intuition, okay, because you can, if you go into states of meditation, you can see very quickly when you allow your thoughts to go in certain directions, you get immediate feedback that tells you you're maybe on the right track. In a way, you're getting feedback from the total system. So you're taking into account all those interactions and you're looking at the final result and seeing, yes, I want to continue in this mode because this is getting me a little bit closer to what I want, okay? Because you're looking at the reaction, all right? I don't know if I explained that very well, but I have a sense of what I'm trying to say. It's not either. It's difficult to find the terms, but.
Yeah, no, that definitely made sense.
Right.
Yeah. I appreciate it.
I posted a little. I posted a link into this dude's research. Let
us not forget that because these companies can only patent mono compounds, all right, that they synthesize, their approach is just the opposite, right? They don't take a systematic approach. They'll throw one compound at something, isolated, not organically bounded, not developed with the balances, the checks and balances that occurs from a naturally produced holistic substance like a plant or whatever, okay? And that's why when they throw it at the body, yeah, they may get some numbed response for the pain that the person's currently experiencing. But now they've got all kinds of switches being turned on and off they don't know anything about. And you get all these side effects that are much worse than the original condition and that further deteriorate the body because they haven't addressed what the original cause was, which is probably something that was out of balance to begin with. And all they've done is further throw the system out of balance, all right? So the concept of meditation is to look at it from more of a systematic thing, just like the concept of a holistic approach to the foods that you eat and clean water and all that. They're taking a total system approach, all right? They're assuming the system has the intelligence to know what compounds to make itself, as long as it's in balance, right? So they're focusing on balance.
Cool. Well, I hate to cut us short here, but I got to go take care of some business. It's trying to make some money. So thanks everybody. Yes, Debbie, and everybody out there in the chat for hanging out with us. If anybody's got any closing statements or anything you want to mention before we roll, or throw a link to your channel in the chat or whatever, please do.
Okay.
I'll put so I remember. Let's see. I'll make you a moderator on in the chat.
I'll just throw in my default.
Actually, know that I know you already. You know, next time I see your avatar.
Yeah, I remember this face.
Exactly.
No, I don't know if I have any closing statements. What's the closing statement? Question everything. Keep questioning.
Yes, critically.
Mm-hmm. And including yourself. Question yourself.
That's my. There you go. Yeah.
Even if it means you're a little confused, better confused than going off on the wrong track.
Yeah, even if it hits your brain, do it even more.
For sure.
Yeah.
Everybody, click on, if you want to follow Debbie, click on that Google link there, and she's got a lot of interesting.
Yeah, I'm going to try to, just to let you know, Graham, I'm going to try to see if there's any way I can, even in an unlisted manner, upload some of the EU 2017 conference videos, as well as the GMO Revealed series that I also, bought the key to. If I can, I'll post it on my G+ page.
There you go. Thank you. All right. Bye, y'all.
Take care.
Peace out.